Hello.
Sir, you have muted yourself, sir.
Hello, am I audible?
Yeah.
Yes.
Yes,
Yeah,
ma'am.
yes.
Yes,
Ma'am.
ma'am.
Yes.
The host.
My screen is visible. Everyone can see my screen, right?
Yes, ma'am.
Yes, ma'am,
Yes, ma'am.
sir.
Visible.
Okay.
Yes.
So we'll start our session within 5 minutes as very few members have joined yet. So please wait for 5 minutes more, then we'll start our session. Okay.
Okay, ma'am.
Okay. Ma'am, I cannot see the
You cannot see the screen.
Yes,
From my side, that's clear, I guess.
it's an issue on my end, but I cannot see the screen.
Okay. So you can try to rejoin the meeting. Just left and then rejoin. Maybe that will solve your problem.
Yeah, ma'am.
Samiksha, good evening. This is Lisa. Whatever the previous semester recordings for the math, it's in the same place or it is in different places? Because I could see a lot of videos now under the IIT BSDS.
Yeah, actually, now for Maths 1 we have Hindi videos. So I think because of that you are seeing uh, so many videos, but the basic content is same.
But it's not clustered, is it? Because it's quite huge and I think different under different names, or it's because earlier it used to be clustered. Now it's not even clustered.
Okay, actually I don't have any idea about that. But I mean, your previous term you see lesser videos, and this time you are finding some new content is there.
Yeah.
Is
But
that the
also
thing?
it's distributed. Not, for example, I think there are topics like people talk, and there is not even it doesn't even say whether it's Math 1 or Math 2. Only the topics are there, even though it's in
Okay,
Hindi
okay,
or
okay. Yeah,
this
yeah, yeah.
thing, but still the topic.
Okay, so
I
only
think it's
session
one of the
name is there,
instructor for the
but week 1 or Maths 1, this thing you are not able to see. This is the thing. Is that
yes. There's not
yeah?
detail there, and it's also good
Huh.
like if you can actually bring it under one roof
Uh.
instead of
Okay.
if it's possible.
Okay. So actually, we thought that if we name our session based on our topic, then it will attract people to join. So that's the
Yeah.
main key
But
idea.
everything is not under math. That's what I would like to say, because I
Okay,
don't know whether
okay.
everybody is recording under individual user or it's under the IIT user thing. I'm not sure.
Mm-hmm.
But
Mm-hmm.
I mean, if you go for a playlist, it doesn't show
Mm-hmm.
everything. Actually, the playlist is entirely only the older ones are coming, not the new ones. It's kind of maybe it's not under one name or one user. I don't know how it works. So,
Okay, okay, okay. Yeah, I will check with that. I will say them that at least
yeah.
put every video over that one playlist of Maths 1. Okay.
On
Yeah,
also
I'll
the
check.
week specified on Math 1 and Math 2.
Mm-hmm.
And it's
Okay.
only for Hindi that you are giving the open thing, not for the English one, am I right?
Right. English one is, I mean, they are same. We haven't changed anything, and we just recorded new Hindi
Okay.
videos for some of the students.
Haha. Okay. Both were start terms. Okay. Thank you. Thanks for clarification.
Hello.
Hello.
Ma'am, can I
Yes.
talk in Hindi or English is compulsory?
No, it's up to you. Whatever,
Okay, ma'am.
Hindi or English, whatever language you are comfortable, you can
Take,
talk.
ma'am.
Madam,
Ma'am,
today's
what are
session,
these TA sessions?
Sorry, what?
What are the TA sessions?
So in TA session, yeah, I will brief this up. So
Okay.
there are 200 students almost.
madam,
Okay,
today
so let's
relations and function will be covered, right? Today.
sets operation, Venn diagram, then we go to relation, and after that function.
Okay.
I mean, so what happened in our course, there will be three main sessions. So these sessions will be taken by our instructors. And the first session will be based on the summary of the week. I mean, already you have watched the professor's video. So what we do, we actually summarize the whole concept, whatever covered in that particular week. Okay. Then after that, the second session will be based on your doubts. So as you, I think, up to this session, you already have been covered the whole theory. So if you have any doubt in theory, activity questions, graded questions, sorry, not graded, practice assignments, you can ask those doubts in this doubt session. And after that, we have a third session, which is known to be a solve with us. So in solve with us, what happened? We actually take some of the good questions from either previous term or some of the new questions, new and a little bit tough questions. So that particular questions will be solved in this session, solve with us. So here what happened, one instructor will be there. He or she will be, give you the question and give you 5 minutes or 10 minutes to solve that particular question. And you just have to try it, live, and then you'll provide the answer. And after that, the instructor will explain what is the solution and how they thought of the solution. Okay. So these are the three main sessions. After that, there will be 4 TA sessions. Please mute yourself if it's not necessary then. Although I'll mute. Okay, fine. So then there will be 4 TA sessions. So in these sessions, TAs will be guide you through some of the activity questions or some of the, again, main important questions. So what happened? These 2 sessions are actually for your practice purposes. Okay, and these 2 sessions will be more fundamental doubts or theoretical doubts. In the doubt session, you can ask any type of doubt from that particular week. Okay. Now, the evaluation process will go through these 3 things. Quiz 1. Yes, Sridhar.
Ma'am,
Sorry,
what are the
Samantha.
quizzes?
Sorry to interfere.
Because in the website there are
just want to
graded
clarify.
assignments.
Based on
Can you speak
the thing,
one by
what you
one?
told,
Sridhar, you go on.
based on your just whatever you elaborated brief just now. So the theory session is the one that you are taking, and the doubt session is the open session. Am I right? Open session that is happening tomorrow.
Yeah,
And
someone
solve
else
with us
was
will
saying
have
something.
practice.
Yeah, right. Similar to
Ma'am,
that.
are the quiz and the graded assignment different?
No. Yeah, obviously quizzes and graded assignment are different. So graded assignment will give you some weightage. I mean, there is one formula based on which your score will be calculated. You can find that formula in, I think, grading assignment. There is some formula which will, evaluate your final score. So in your final score, there is some weightage of graded assignment, some weightage of quiz 1, quiz 2, and enter. So you can just go through the whatever the grading document is there on portal. So in that grading document, you will find a formula how your eventual score of the this particular course will come. Okay. So what happened in quiz 1, there will be again 12 to 15 questions, and these questions will be of 2 marks, 4 marks, and total marks will be 50. And after that, we convert these marks into 100 and then calculate according to this formula. There will be one formula.
Ma'am, where can I find the formula?
There is one grading document is given to you by support team, or there's one grading document in our portal. If you won't find it, I will show you at the end of the session. I have that for
Okay,
a particular
thanks
formula.
a lot.
Yeah.
Student handbook.
Yeah, student handbook or something. If someone
okay,
can share that PDF into chat box, that will be helpful. If
No,
someone
ma'am,
has
I
already
found
done.
it. I didn't know the file name was handbook. I can find it myself.
Yeah, fine. So that is the particular formula. Then again, quiz 2 will be of the same pattern. And in quiz 1, we have the syllabus from 1 to 4 weeks. And all these things, syllabus and all those things, we actually give you one revision session, and revision session 1 and revision session 2. So all these particular types of questions you can ask there, and we'll address them. Okay. Quiz 2 will be again similar pattern as quiz 1. The syllabus for quiz 2 will be 4 to 8 weeks. And again, there will be 12 to 15 question worth of 50 marks. And again, we will convert it according to our formula. And then there will be one end term. And end term, again, it's also worth of 50 marks. same pattern. But in end term, what happened? The syllabus will be from 1 to 12 weeks.
Quiz
Okay.
to 5 to 8, madam.
Yeah, 5 to yeah, 4 weeks you can divide. But in end term, we actually ask some of the questions from 1 to 4 and 5 to 8 also. Okay.
So,
So
ma'am,
that's
now we
yeah.
have a exam on 27th October, right? Which exam will that be?
That will be your quiz 1 qualifier exam.
Okay.
Yeah.
Okay.
If you
So if we
qualify that,
qualify in
then
that, then we will continue with quiz 2 and end term, right?
yeah. This is same as
Okay, okay.
qualifier exam.
Are the same questions going to be asked in the qualifier exam as the quiz 1?
Yeah, we have 2 sets, so sets will be shuffled between the students. So you can assume that these two this is only one exam, and they called out different names. If some students are already qualified and they haven't joined in the previous term, then they can join in this term, and they will be given to be a quiz 1, and others will be given as a qualifier exam. Okay.
So, ma'am, will all quizzes be held offline?
I think you have given some centers. These
Yeah.
papers are
So I'm
CBT,
just
right?
asking whether if all quizzes will be held offline.
Yeah, correct. All quizzes will
Okay.
be held off.
In the
Okay,
orientation
ma'am.
foundation, I heard like 2 has 1 to 8 weeks portions like that. I heard.
Sorry, what? I'm not able to understand.
Quiz 2 in the
Hmm?
foundation orientation, I heard like week 1 to 8.
Yeah, actually, this thing actually happened in last. There will be, you can assume one question, but the major portion or 90% of the quiz 2 will be from 5 to 8 only. Because we already judge you from 1 to 8, right? Quiz 1 will evaluate how.
Like 1 to 8, so that is.
Yeah, but the more weightage will be from 5 to 8 only.
Okay.
Yeah.
Ma'am, I have a question.
Yes.
Ma'am, I was actually going through the calendar where our TAs and everything are already marked in. That is where I see that on some sessions, let's say if I take example of 2nd of October, I see our session is also overlapped with some other subject as well. Like if I see that on 4 to 6 we have a session on 2nd of October that is also overlapped with another subject called English from 5 to 6. So like is it something like I'm a little bit confused.
No, such
like how
things won't happen. If there is some collapsation is happening, then we will take care of it. We don't want you to skip one session for the other subject, right?
Yeah,
So we'll take care
calendar
of
will
it.
be updated.
Yeah, calendar will be then updated.
Okay, great. Thank you.
Basically, that's a
Ma'am,
technical bridge.
will foundation students give a quiz 1?
Yeah, all foundation students will give quiz 1.
Okay.
Ma'am, for the students, for the J entry, they'll give what quiz?
Yeah, for JEE students, I think they are already qualified, right? You are already
Yeah,
qualified
that's
because
why
of your JEE
that's
score.
what I was
So,
asking.
so you have to you have to give quiz 1 because these marks will count in your total marks of this course, right? So for you guys, this paper will be known to be quiz 1, and for those who haven't qualified yet, they will learn this paper to be qualifier exam. So you can assume that quiz 1, qualifier exam, these both are same thing. And every foundation student whoever want to join this program, they have to give quiz 1, quiz 2, and intern. And I'll suggest better to give quiz 1, quiz 2, and intern 3 exams. Okay, some people what they do, they obtain good score in quiz 1, then they simply jump up to intern or something like some student can do. But although you have to give these 3 exams. It's not that compulsory, but I'll force you to give these 3 exams because it will give you a very good practice. Okay, yes, someone was saying something.
Okay, ma'am.
Ma'am, are these compulsory? Suppose I don't have any doubt for that subject on that particular week. So do I have to join these sessions?
See, you can go through this formula. In this formula, there is one section where they mention some best of quiz 1 and quiz 2. So if you want that your score will be calculated using this part, then you can skip.
I am asking for the live sessions.
Sorry, what? You are asking for?
Do I have to join these live sessions?
It's up to you, but it's better to join. It's up to you. If you don't have any
doubt,
ma'am, what will be the timings usually?
Usually, the session will held from 8 to 10. I don't know the timing
Okay.
about TA sessions, but yeah, these 3 sessions will be from
Because the
8
TA
to 10.
sessions will collide with my college timing, ma'am, so I won't be able to
Okay,
attend
so
those.
you can ask them to shift, right? You can just inform
Okay.
them that you have some other
The
you have
sessions
some
are
other work.
recorded too. You can access from YouTube also.
Friends, can we
That thing
start the
also you
Yes,
can
session?
do.
These
that
program-related doubts
also.
can be solved elsewhere. Can we start
Sorry,
the
what?
session? We are
Yeah,
getting
yeah,
late.
Yeah,
yeah,
yeah, I'll start
yeah,
the
yeah.
session.
Yeah, I
Okay,
was.
fine.
Where can we access the recording again?
IIT
Uh,
Madras official YouTube channel. You can search.
okay, so
Ma'am,
let's
In our
go ahead. Yes,
in our
those
qualifier,
living abroad, how will they access the quiz?
just a second. What you're saying, Aruba?
Those who are outside India, how would they access the quiz?
How will they access the quiz? I think they will give you some center nearby your, your hometown or whatever city you are located.
There are
You can ask
specific
this thing
centers.
to support him because I don't have any information for.
Yeah, ma'am, all these questions are just time pass. Let's focus on the question.
Yeah, actually,
Already have
we
conversation.
already have been
Yeah.
instructed to give 30 minutes for these questions because
Achha,
it's
okay,
your
okay.
first day, so it's better to get hand on the material.
Okay,
After that,
okay.
what happened? After 3 to 4 weeks, students was like, we are not able to access the content. So this thing should not happen, right? So that's why, okay, fine. Any other doubt if you have, or else we'll just start the session, and if someone has doubt, then I can address them at the end of the session. Okay.
hello, ma'am. I have a doubt, ma'am.
Okay, we'll take all technical doubts at the end of the session. Okay, let's start the session first.
Excuse me,
Although
ma'am.
if someone
I have a doubt.
doesn't have doubt, it will be waste of time for them. Okay.
Yes.
So now I'll mute you all. After that, I'll explain one topic, and if there is doubt in that particular topic, you can raise your hands, and I will unmute you. Okay, is that fine for everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
That's better.
Yes,
Yeah.
ma'am.
Yeah, ma'am. Fine. So let's start. So in so it's a particular course for maths. Okay. So in maths, we start with set theory. Why we start with set theory? Because set theory is basically the language of mathematics. Whatever term or whatever concept we want to describe in maths, we use sets. So that's why sets are very basic notion or basic concept in maths. So you'll first try to understand our number system. So what is the number system? So you have some, suppose you see some objects and you want to count them. So what the numbers you will use? You use 1, 2, 3, and so on. So these numbers are known to be the natural numbers, and the set of natural numbers is actually denoted by this particular n. Okay, this is a special notation given to the set of natural number. In our course, we involve zero in our natural number. Many places, many textbooks or many institute or many people won't allow zero in their natural number. They just give us a new name to be the whole number. But it's okay. In our course, we say that zero is our natural number. Okay, so this is one convention. Now we come across one thing that if we take any two natural number and if we subtract them, suppose I'll take 5 and 6, these are two natural number, and if we subtract that, we will get some result, and this result is not a natural number. Okay, so this -1 is not a natural number, so that's why we have to extend our set of natural number and we jump to the set of integers. So what is the set of integers? So set of integer will contain all the natural numbers 0, 1, 2, 3, and so on, and the negative integers -1, -2, -3, and so on. So this set is known to be the set of integers. Now, as we observe the operation subtraction, now if we observe the operation division, then it's pretty much clear that if we take any two natural numbers, suppose 2 and 3, and if I divide 2 by 3, then again, this result is not a natural number. Okay, and again, this result not even an integer. So that means we have to extend our set further. So that's why we extend our set and reach up to the set of rational numbers. So what is the set of rational number? So set of rational number is nothing but all tuples p comma q. So we generally denote any rational number in the form of p by q. And here p and q are what? So here p and q are your integers. So if you take any two integers p and q and just place them in the form of p by q, so that number is known to be the set of rational numbers. So you can easily observe that if you have any integers, so let's say you have m, which is an integer, then this m can be written by m by 1, right? And again, 1 is an integer, m is an integer, so it's a rational number. So that means every integer is also a rational number. Okay. Now what happened? There is one very good observation. I mean, you can use Pythagoras theorem. So suppose if you take one unit square, so that means it's a square, and the length of each edge is 1 unit. And if you compute the length of this diagonal, so the length of this diagonal is √2, right? And you can compute it via the whatever Pythagoras theorem is there, right? 1 square plus 1 square. So that means this is one specific, I mean, real quantity. It's a real length. You can see it. You can, right? There's a one real length which is actually not a rational number, because you can easily show that √2 is not a rational number. It is not a rational number. So we have one number, we have one quantity which is not a rational number. So that means we need some more numbers in our sets. So that's why we include all such type of numbers which are not perfect. They are known to be the irrational numbers. So what are the irrational numbers? Irrational numbers are √2, √5, pi, e. All these numbers you will see in your upcoming weeks. Okay. So that's our number system so far. So what happened now? If we take all the rational number and all the irrational number together, then this set is actually be the real number. All the rational numbers and the irrational number, and the set of irrational number actually denoted by this QC. Okay. So the set of rational number and the set of irrational number combined with give us the set of real numbers. Okay. And again, in real numbers, we have multiplication operation. And because of the multiplication, we can define the square and square root, right? So suppose you have a number 4, right? So 4, and if you do the square root of 4, what is it? So it will be 2. So that means 4 is a number whose square root is 2. So that means what happened? That if we do 2 square, then it will be equals to 4. But what happened if we do the square root of -1? Then this is not a real quantity, right? So again, we further extend our set of real number to be the set of complex number, and the set of complex number is nothing but all the numbers of the form a plus iota b, where iota is nothing but under the root of -1, where your a and b are the numbers coming from real numbers, set of real numbers. So this is a basic real number system. I think you guys are already familiar with that. But the main key observation is that the set of natural number is contained in set of integers, is contained in set of rational numbers, and this is contained in set of real numbers, contained in set of complex number. Okay. And again, set of irrational number is also contained in set of real number, and same thing with complex number. Now there are two main notions. First thing is the GCD, and the second thing is the factors and the primes. Okay. So I'll go to that, but before that, there's one remark I want to make. So the remark is that the rational number does not have any unique representation. It does not have unique representation. So that means if you take any rational number, so let's take again 2 by 3. So this is a rational number, but this rational number will be same as if you multiply it by 2 to the numerator and denominator as well. Then it will become 4 by 6. So that means this rational number 2 by 3 is same as this rational number 4 by 6. So that means, okay. So actually I'm looking at the chat now. Is there anything specific? Okay, fine. So that means for any rational number, we don't have unique representation. But actually this unique representation thing will help us to demonstrate how we can add two rational numbers, subtract two rational numbers, right? So suppose you want to add two rational numbers, v by q plus r by s. So what you can do, you can make some changes. You can add, you can multiply and divide by some number so that the denominator will become same. So that means if I multiplied by s and divide by s, and here if I multiplied by q and divide by q, then these two rational number won't change. And the sum of the rational number, we can easily say that the sum of these two rational p by q plus r by s, this is nothing but sq, and this will be ps plus rq, right? So this thing that every rational number does not have unique representation will help us to denote to demonstrate how we can add two rational numbers and subtract two rational numbers. Okay. The next thing is factors. Or before that, let's first know the factors. So what do we understand by a factor? So suppose if a number a divides another real number b, if an integer divides another integer b, then we say a is a factor of b. Okay, so this is a definition of factor. When we say a is a factor of b, if a divides b, then we say a is a factor of b. Now what are the prime numbers? So any integer, any number p is prime if the factors of p are 1 and p, right? So if a number you have and the factor of that particular number is only 1 and p, then that particular number is known to be a prime number. Okay, so that means we are using the definition of factor to give a definition of prime numbers. Okay, and the third thing is the GCD, greatest common divisor. So what is a GCD, greatest common divisor of any two? Okay, so let's say we have two numbers a comma b, and then the GCD of a comma b will be the greatest common divisor, right? So it will be the largest number. So it will be then GCD of a comma b will be the largest number d, which divides a and b both. Okay, so that number is known to be a GCD. So that means if you take any two number and find out what is the largest number which divide a and b both, then that number is known to be a GCD of a comma b. Okay, now there is one thing which I think most people will confuse with this, is known to be the notion of modulus. So what is modulus? So if someone says that a mod b is equals to c, right? So if someone says a mod b is equals to c, that means if you divide a by b, then the remainder will be c, right? So what is the meaning of this phrase a mod b, modulo? So a mod b means so if you divide a by b, then the remainder will be c. So that means this particular a is nothing but some integer, some k multiplied by b plus c, right? Because if you divide a by b, then your remainder will be c. So modulo is nothing but a way to convey what will be the remainder if you divide one number by another. Okay, and this modulo actually a little bit, it seems to be confusing, but if you understand the basic meaning, what is a modulo b means, if you divide a by b, then whatever the remainder will be, that remainder is known to be a modulo b. Okay. So for example, you can easily write that 26 modulo 5 is nothing but 1, right? Because if you divide 26 by 5, your remainder will be 1. So this modulo actually used, so many places you can find out this modulo terminology. So it's better if you get comfortable with this modulo thing. So whenever you see a mod b is there, so a mod b is nothing but if you divide a by b, then your remainder is known to be a mod b. Okay. So far any doubt? If you have any doubt, you can raise your hands. I'll ask you to unmute one by one. Okay, Rahul, you can unmute yourself.
Ma'am, the polynomial is a portion of week 4 qualifier portion or not?
Yeah, polynomial will covered in week 4, so it will be a portion of quiz. If you have any doubt in this concept, you can ask. Otherwise, please lower your hand.
No.
Okay. Karthik, you can unmute yourself.
Thanks, ma'am. My doubt is related to arithmetic operations where there are certain questions that I've seen, like square root of 6 plus square root of 3 divided by square root of 6 minus square root of 3.
Right.
Yeah, we have seen this in a very primary, but I've been out of touch of those summations.
See,
So is there any references that I can get to practice?
references, you can go to NCERT where they introduce the notions of rational number and these all things. There you can find out these type of questions. Other than NCERT, I don't know. But these are the standard questions. So here you just have to use the rationalization method. So although you can go to NCERTs for reference.
So this is called as rationalization, is it? Like
Yeah,
the topic that I should search for. Okay.
Yeah, you can search for rationalization method. So you can find out these questions.
Okay, thank you.
There's one Naveen, you can unmute yourself.
Hello, ma'am, am I audible?
Yeah.
Ma'am, my basically doubt is that the mode topic, ma'am, there are term also called mode, where if we give some input, basically that's in inequalities and that all, then this mode is different from that mode.
Mod means you find out the modulo function, this mod of x. Are you talking about this thing? This is sometimes known to be modulus function or sometimes known to be absolute function. So this mod and that mod is different. This is a function. This is some way of expressing what is the remainder. That thing.
And ma'am, one more. And please mute the chat. Please disable the chat. All are promoting the WhatsApp group links and all.
Chat. You are going asking about.
Yeah, all are promoting the WhatsApp group, and this pop-up message is visible on the screen, and the screen is not clearly visible.
You're talking about my screen. Okay. So you can, from your end, you can do that, because if I do, then I'm not able to see people's doubts also, right? So you can just go on your Zoom setting and enable chat notification. That will help you. On your personal Zoom, you can do that setting. Okay. Okay. Yes, Prathamesh, you have any doubt? Do you have any doubt? Okay, there are so many handed now.
Yes, ma'am. I want you to explain discrete and dense terms of related to numbers, real numbers, and all.
Sorry, what?
Ma'am, I want to you to explain dense and discrete terminologies.
Okay, dense and discrete terminology. Yeah. So actually, what happened? There is one dense and discrete. So what happened? Dense means if you have any two numbers, and between those two numbers, if you are able to find another same type of number, then that particular set is known to be the dense set. For example, if you take any integers, so suppose you will take two integers. Let's name it to be. Let's take 1 and 2. So there is no integer between them. So if you see your real line, so this is your real line. There's some 0 here. There's some 1 here. There's some 2 here. So in real line, there is a huge gap between the number 1 and 2, right? And there is no integer between 1 and 2. So that means there are so much, you can understand this by a gap thing, that if you find out two integers, then you can easily find out a much larger gap between them. So that thing is known to be a discrete set. Although there are formal definitions for that, but it's not in your course. So for now, if you want to understand what is a discrete set means if you take your real line and if you have two integers, then you can easily find out so much gap between them. So this gap actually says that your set of integers is discrete. Similarly, we say that the set of natural number is also discrete. But what happens if you take any rational numbers? So suppose if you take any rational number p by q and r by s, and if you take the average of these two rational numbers, so suppose p by q plus r by s by 2, then this again will become a rational number. So that means what happened in real line, if you take any two rational numbers p by q and r by s, then you can easily find another rational number which is lying in between them. So that means there is no gap between any two rational numbers. Gap means you should not find out any rational number here. But what happen if you, no matter whatever rational number you will take, you can easily find out one more rational number in between them by just taking their average, right? So this property is known to be the denseness property. So what happens? The rational numbers are known to be dense. So you cannot find any gap between them. So suppose this is a rational number, this is the next rational number, then you can easily find out one more rational number between them. So there is no gap in a rational number. That's why they say it to be the dense. And you can easily find out a huge gap in integers or natural numbers. So these sets are known to be a discrete sets. Okay. Is that clear? Who asked this question?
Ma'am, please repeat again.
See, what happened? What is a dense set? So dense means if you have two numbers, you can easily find out any same type number in between them. For example, if you take any, suppose I'll take 1 by 2 and let's take this will be anything you can take 3 by 2. Okay, so these are two rational numbers. So 1 by 2 somewhere sit here and 3 by 2 somewhere sit here. But in between these two rational numbers, you can find out again a rational number which is nothing but 1, right? 1 lies between 1 by 2 and 3 by 2. So 1 is a rational number which is lying between these two numbers. Anyhow, these are the particular rational numbers. But if you take any rational numbers, I'm not taking any specific, any rational numbers, you can easily find out another rational number which is actually sitting in between them, right? So such kind of behavior is known to be denseness. Denseness means there is no space, right? There is no space in between any two rational numbers. Again, if you thought of that there is a space between these two rational numbers, but again, if you take the average, you can find out again one rational number. So that means there are some kind of denseness is there. Denseness means you can say that there is no place to sit, some kind of that thing. You can say that if you just take any rational
You
number,
mean to
you
say
can
it cannot?
easily find out. Someone was saying something.
So you mean to say it cannot be a void?
Right.
Correct?
I mean, you cannot say that you have one rational. I mean, you cannot describe this terminology that this is a previous rational number, this is a next thing you cannot describe, right? Because
Ma'am,
1 by 2, after that, if you say 3 by 2 is the next rational number, then this is not possible. One will be there.
one
Yeah.
doubt. Ma'am,
Yes.
this is a recorded session will be available in YouTube.
Yeah, all recording will be available on YouTube. You can go
Thank you,
after
thank
that.
you.
And, yeah.
Ma'am,
So,
I have been unmuted. Shall I ask my question?
yeah, you can ask your question because this
Okay.
denseness is there. Just 1 second. So in denseness, what happened? You cannot define what is your next rational number, next element, right?
So,
Because
ma'am,
again, there is one.
regarding
Yeah.
the denseness, can we say that in between the numbers 1 and 2, there are infinite?
Yeah, we can easily say there are infinitely many rational numbers because what happened? You can divide by 2, you can divide by 4, you can divide by 5, and so on. So there are infinitely many rational numbers between any two rational numbers. So this is the thing is happening. I mean, in between any two rational number, you cannot find any space. If you right. So this is known to be the denseness thing. Whereas in discrete thing, you can find out a pretty much space, and you can easily define the terminology next.
So,
Yes.
ma'am, it means between two rational numbers, so infinity number of rational numbers are there.
There are infinitely many rational numbers between any two rational numbers.
So it's a distance between them is going again. If you're divided, combining this or midpoint, it will be goes very dense. That's why you are having
Right.
this.
That's why there's terminology to be dense. There's one more reason known to be dense, but let's forget about that. It's more complex.
So ma'am, it's like there's no empty space between them.
There is no space between the two rational numbers, and
Can
you
I
cannot
add
define
something
the
to it?
terminology of next. So that's the thing of denseness. And in discrete, just opposite of dense, some kind of opposites of dense. You can see that they are
Can
pretty
I
much
add
the same.
something to the discussion, please?
Okay, ma'am. Thank you.
Sorry, what?
Can I add some to this question?
Can I also ask one more question, ma'am, please?
Yeah, you can ask.
So,
ma'am,
can we say that dense rational numbers are dense and integers and real numbers are discrete because we can see a
Real
interval
numbers you
between them?
cannot say discrete because
I'm
rational
sorry,
numbers are real numbers.
naturals
So,
and integers. Naturals and
naturals and
integers.
integers are discrete, and rational, reals, irrational, complex, all are dense.
All are dense. Okay, thank you.
Ma'am, can you reiterate the part where you told that real and rational are subsets of complex?
Yeah, so what happened? Real number. So what is a complex number? Complex number is of the form a plus iota b, where your iota is nothing but square root of -1, right? Where your a and b are actually real numbers. This notation is for element. Okay, I'll describe this later. So if you take b is equals to 0, then any real number, suppose I'll take m to be a real number, then any real number m can be written as iota, I mean m plus 0 iota, right? So it's a complex number. So that's why we say that the real number set is a subset of complex number. All those notations, set, subsets, I will discuss in this lecture. Okay.
So rational
complex number.
And similarly, you can say that since the rationals are subsets of real, so this thing follows, right?
So, ma'am, rational are subset of irrational and irrational is subset of real.
No. Rationals are not subset of irrational. Why we develop the set of irrational? Because we have something more than rational. Root 2 is a one number which cannot be expressed as p by q, where p and q are integers, right? So that's why we have irrational number. So rational number and irrational number are totally disjoint. There is no number which is rational or irrational both. Okay.
So, ma'am, suppose you have taken the example of root 2. So, root 2, if I can calculate on my calculator, it comes out to be something around 1.7 something, right?
No, that's an approximation because your calculator have limit. I mean, the calculator can show you up to 10 digits or 12 digits or 15 digits.
1.414, something like it keeps on
But
going.
it's not an exact value. That's the thing.
So,
that's
so
why.
ma'am, any root value which goes on repeating itself to an infinite thing, so it becomes an irrational number.
Actually, there is two notation of rational, irrational according to the decimal places. Okay, decimal thing is a little bit different. I'll come to that at the end because we haven't discussed decimal representation of rational or irrational. So I'll discuss it at the end because we haven't discussed how to decimally express any rational. There's a very similar thing. Okay, let's. After completing, I'll tell you, okay, what happened if you express some number in decimal, then how it's rational or irrational. Okay. There is a one or two rule, repetition rule or conversion rule. That's all.
Repetition and conversion rule.
Okay. You can search on Google also. What is the decimal?
So, ma'am, a real is.
Ma'am, can I ask the question?
Non-terminating thing?
Yeah. Just wait a second. Someone says.
So, ma'am, real is a subset of complex number. So, complex number is at the top of the chart for us, right?
Yeah, right. Yes, Kashish. Kashish is saying something or someone is saying something, right?
It's me, Raghu, ma'am. You've given an example of rational numbers, which is the form p by q, and irrational numbers, for example, pi or square root of 2. But when it comes to the set above it, which is complex numbers, can you give a real-time example of similar sort? Because all I see is the notation that you're explaining, m plus.
So actually, complex number we haven't that focused in this course. That's why I'm not giving. You can take any number. Let's take 1 plus iota type of. This is one complex number.
Numbers are imaginary, no?
Complex numbers are imaginary number, but there are certain theory developed for complex number. So you can just, for now, time being, you can assume that any number of this form is to be a complex number. That's it. Okay. If required, then you can in Maths 2 or someone in other course you can study these complex numbers. Okay.
Okay.
So
in
let's.
part 1 is not required, is it?
Yeah, part 1 we don't require complex numbers.
Okay.
Ma'am. Hello.
Yes, was there?
Ma'am, greatest common divisor. Explain with the example.
A greatest common divisor is the largest common divisor if you divide a and b. Suppose you have two numbers. Let's take it to be Anything you can take. Let's take 18 and 24, right? So what are the divisors of 18? So 18 are divisible by 1, 2, 3, 6, 9, and 18 itself, right? And 24 is divisible by 1, 2, 3, 4, 6, right? And 8, and then 12 and 24 itself. So what happened? These are the divisors of two particular numbers. From these two divisors, you have to find out a common thing which is greater. So here 1, 2, 3, 1, 2, 3 are common and 3 is greater. But since 6 is also common, 6 is the greatest number which can divide both of the things. So that means the greatest common divisor of 18 and 24 is nothing but 6. Okay, so this is the notion of GCD. Is that
Ma'am,
fine?
can I ask a question, ma'am?
Yeah, your voice
Out
is
of the
breaking.
box. Is it
Yeah, you
audible
can
now,
ask.
ma'am?
Yeah.
Ma'am, actually, I'm unable to join the live sessions of any subject. ma'am.
Okay, you are unable to join. Okay, so what we
Even though
can.
I have
Huh?
connected it to Google Calendars, ma'am.
So what you can do at the end of session, just please mute yourself. Just 1 second. So what you can do at the end of the session, just give me your email ID. Okay, I'll ask support team to check your profile. At the end of the session, just remind me. I'll take your email ID and I'll report them. Okay.
Okay, thank you.
Okay, so for now, I'll just mute you all. Wait
Even
a
I am
second.
also not able to join.
You're also not able to join?
Yes.
So
I am
whoever
also
is
not available.
facing some technical issues, they can give their email ID to me. I'll
Hello?
inform to the support
Hello?
team and I'll report you in the next session. Yes. Hello.
Ma'am, can I ask a subject related doubt?
Yes, Kashish.
Hello, ma'am. Can you hear me?
Yeah.
Ma'am, I have some doubts regarding the solving of the activity questions. Ma'am, I am facing some issues that in the lectures, the every concept is not covered. So I have to spend a lot of times on live sessions. What can I do, ma'am? I have to choose one thing, or either live session or the recorded session. But in the recorded session, there is some conceptual clarity is not
Okay,
given.
we'll discuss this at the end. I mean, I'm able to understand what you're saying, so I'll brief you.
Move to next topic, ma'am.
Yeah. Yes, Kashika, you have one doubt. So after that,
Yes,
I'll
ma'am.
just mute you.
I have a statement, don't know if it's correct or not. Ma'am, we
Mhm.
don't consider 1 to be a prime number because two factors are supposed to be two different numbers. So it can't be 1,
Yeah.
1.
Correct.
Okay. And the other doubt I had, ma'am, do we need to remember the log division for in the case of rational numbers like root 2, root 3? Is it needed to remember long division? How to
No,
find
no,
it?
no. No, it's not needed. Not at
Okay.
all needed. Yeah.
Thank you.
Ma'am,
Okay, so yes.
ma'am, one small doubt.
Uh-huh.
While we are taking under root x, why can't we take negative numbers practically in graphs?
Because if you under the root of -1 does not make sense because
Not like that. Under root of
Flex
for
number.
suppose we have under root of 36.
36. So it will come out to be a good
Integer.
number, not 6, integer. So we
Why
don't
can't
want,
we
and
take
this is a
minus 6
rational
whole
number.
square?
Oh, sorry, what?
Why can't we take as -6?
Because -6 square is also 36. Here, I mean, see what happened. Yeah, this is a one big confusion happened to. See what happened. There is one notation known to be square and square root. So suppose you have a number 6, and if you do square, then it will be 36. -6 square is also equals to 36. So when we want to say that the square root of 36. So if you do the square root of 36, it can be two numbers, plus square root of 36 minus square root of 36. So if someone writes you minus square root of 36, then you will say it's -6. And if someone writes you plus root of 36, then you say 6. Okay. So for removing this confusion plus and minus, we try to write in terms of this under the root of 36 and minus under the root of 36. This is the one
Not like that,
convention we
ma'am.
use.
Not like that. And we can write it as under root of -6 whole square. Then square and root cancel it, have -6, right?
No. But square root won't work like that. I mean, what you are saying, your confusion is correct. But what happened? This term, this thing is It's a function. So I'll cover this doubt in the when we talk about the functions domain, then some definition there. So what happened? The square root is a function, and the domain of this function is all positive number. That's why we cannot take -6 and then do a square of that.
Okay, ma'am.
This
Thank
type
you.
of thing is little different.
I got it, ma'am.
Okay. Yeah. Fine. So now I'll move to set union functions relations. I mean, I'll cover up to, I mean, most of the theories,
Excuse me,
and
ma'am.
after that I will unmute. Yeah.
Ma'am, I have a doubt regarding the rationalizing method. So, when I read my class 11 book in complex numbers, there is a term called conjugate, taking of conjugates. So, what is
Right,
the
right.
difference between rationalizing and taking conjugates?
There is a little difference. I mean, rationalization is used for, I mean, rationalization is a process in which you will just suppose you have something here, something here. So you will just change the sign and multiply and divide by that thing, right? This is a rationalization. And the conjugation says that if you have a complex number a plus iota b, then the conjugate of that is z bar, and it's a new complex number, and it's denoted by a minus iota b. Okay, so this is some kind of behaving like a function. You will learn about the function, and this is some particular method for solving some type of problem. So that's a little difference, although they are same. You can assume that they are just named to be different, but this is one used for solving problem, and it's actually defined for some purposes. Conjugation is defined for some purposes. If you go ahead, you can see that there are so many properties a conjugation of a complex number can have. But rationalization is simply just a method. You just multiply and divide by some quantity. That's all. To simplify your expression. Main aim is that, to simplify or whatever given expression. Okay, is that
So,
fine?
ma'am, so can we conclude that rationalization is used for any kind of real numbers and conjugate is used for complex numbers alone? Am I right?
Yeah. You can say that. But although conjugation of real number is same, so that's why we don't talk about conjugation in real number. Because conjugation only apply when there is only one iota is there. That's all. Okay.
Okay, ma'am.
So now I'll mute you all. Just NCRT books are enough or not, I can't say that. I mean, NCRT is some extra material, you can say. But for you, your priority should be lectures and activity and practice questions. These three things and graded questions, obviously, solve with this question. These 5 things are more than enough for you to clear this course. That thing I can say. Just go through lectures, go through activity questions, practice question, graded assignment, and solve with this question. That's all. Okay. What is NCRT? Okay, fine. So let's I'll mute you all. I'll cover all the topics. Just take one notepad or something with you. If you have any doubt, just write it down, and I'll take all the doubts at the end of the session. Okay, is that fine for everyone?
Yes, ma'am.
Okay.
Ma'am,
Yes,
till
ma'am.
what topics we will be covering today, ma'am?
Yeah, relations, sets, set operation, whatever cover in week 1, that much. Up to function, bijective function.
Okay.
Fine. So let's go to sets now. So what is a set? Set is nothing but a well-defined collection of objects. Suppose you want to collect some objects, and that collection in mathematical language is known to be a set. For example, if I want to collect all the natural number up to 10, then this that collection is my set, 1 to up to 10. Okay, so this is a set. So now for set, there are now how you can denote a set. So how we write a set. So for set, we have 2 to 3 notions. If you want to denote, if you want to write a set, first thing is just listing out the elements. For example, I have this set. Let's say it contains some elements A, B, C, D, right? So one thing I can do, I can just list out the elements A, B, C, D, right? And another thing is known to be the set comprehension notation. So what is the set comprehension notation? Set comprehension notation allows us, give us some particular format. So this is a format for set comprehension notation. So, I mean, it uses this curly brackets. Here you will be list out your elements. How your elements are the members of set. Whatever things are there in set, that things or that objects are known to be elements. So here A, B, C, D, these are the elements of our set. Now, what is the set comprehension notation? Set comprehension notation will give us a very brief form to express any kind of set, because see, this listing out thing, that this making list, this thing is only feasible if you have a finite number of elements. But since we have so many sets which contain infinite number of elements, so this listing thing cannot help. So that's why we have to come up with another notation, which is known to be the set comprehension notation. So set comprehension notation, divided into two parts. First thing is the element, and the second thing is the relation. What is the relation? This relation is our general relation. I mean, it's a condition type of thing, you can say. Instead of relation, let me use the condition name. So there are some condition on these elements, that what type of elements you have to collect. So in this condition, there are two parts. First part will say that the elements come from where? That the elements, sorry for this. I mean, what type of element is actually you want to collect? What element? What objects or what elements you want to collect? And this thing actually used one set. I mean, you want to collect some element from other set, and that set is known to be the existing set. So in set comprehension notation, we have two parts. First thing is the element, second thing is the conditions. In conditions, we have one existing set. So that means we want a larger set or a universal set from which I have to collect some particular type of element, right? So that set is known to be the existing set. And there are some condition that what type of element from this existing set I have to collect. For example, if you have, if you want to collect all even numbers, or you want to give a set comprehension notation for the set of all even numbers, then what you can do? So you can say that I want to collect all the even numbers are what? So even numbers are natural numbers. So that means I want to collect all the number n in such a way that n are the natural numbers, right? So this is my existing set now. And what is the condition here? So since I want to collect all the even numbers, so that means every even number is divisible by 2. So correct, x mod 2 or n mod 2 is equals to 0, right? So this is a very basic example of set comprehension notation, how we can, since again, infinite, I mean, we have infinitely many even numbers, right? So if we want to list it out, then it's not possible. So what we can do, we can take our set comprehension notation and just observe it, okay? So that means all n belongs to natural numbers such that n mod 2 is equals to 0. Now, set comprehension notation you can learn in several ways. I mean, there are so many sets which you can say, but let's move to subsets and all. Okay. So what is a subset of a set? Subset of a set. So suppose you have a set A. So then if you take some elements from this set, suppose this set contains some element, let's say 1, 2, 3, 4. And if you take some particular element from this set and make a new set, so if you make a new set B which contains one thing, then this B is a subset of A. So that means B is a subset of A if it satisfies this condition, that if B belongs to B implies B belongs to A. So that means every element of B is an element of A. So if every element of B is also an element of A, so then we say that B is a subset of A. Now there are two very basic subsets of every set. Suppose A is a set. A is a set. Then if you take a set which contain nothing, for example this type of thing, right? So this is a set which contains nothing. So this is known to be the empty set. An empty set is denoted by 5. So this is the empty set. Empty set means is there is no element in this set. It's just a set. It's a collection of nothing, or you can say that it's a collection of something which is not possible, right? So if I say that collect all the, list out all the months which has 32 days, then we know that there is no month of 32 days, right? So that means this collection is 5. There is nothing in that set. It's known to be an empty set. So again, by our definition, empty set is a subset of every set. and every set itself is a subset of itself. I mean, A is a subset of A, because although every element of A is in A, so that means it's satisfying my this condition. This is a definition of subset. If B belongs to B implies B belongs to A, then B is a subset of A. So using this definition, we can easily say that the empty set is a subset of A and A is a subset of A. It means every set is a subset of itself. Now there is one another notation is known to be the power set. So what is a power set? So power set is nothing but a set of all subsets of a set. That means it is a set. It is a set of all subsets of A. Suppose A is your set, and if you collect all the subset of A, then that set is known to be a power set. And very two basic element of power set is the empty set and the set itself, right? Because they are subset of A. If you take any set, then phi and A are the subset of A. So that's why phi and A are the very basic element of our power set. Now there is one result which says that if A has n elements, suppose A is a set and it has n elements, then power set of A, and generally power set of A is denoted by P of A. So then the power set of A will have 2 to the power n elements. Okay, so if you have a set with n elements, then its power set will have 2 to the power n element. And the proof of this fact you can see in lectures. It's very basic proof. I mean, because every element, suppose this is my set A, and there are n elements, so let's denote them by A1, A2, and so on, En. So now if I want to make a subset of this set B, suppose I want to make a subset of this Hello, am I on now? Hello. Hello. Okay. Just a Yeah, actually there is power cut happening area, so that's why I got disconnected. Okay, let's start again. Where were we? We were at power. Power set. Power set is nothing but direction of subsets of a particular set. Okay. So again, there is one result. So if you have a set with n elements, then the power set of A will have 2 to the power n number of elements. And why is this so? So suppose you have a set with n elements. Let's name the elements to be A1, A2 up to AN. And if you want to make any subset of this particular set, then you have two choices for everyone, right? Either you can take this A1 or you cannot take this A1, right? In your particular set. Again, A2 has two choices. You can take A2 and you cannot take A2, right? Again, our basic permutation combination rule. So that if you want to make a subset for every element, I have two choices. So that's why the total number of subsets will be 2 multiplied 2 multiplied. Okay, so is there anything? I'll unmute you all then.
Ma'am, just can you repeat, ma'am?
I asked wait.
Ma'am, please repeat the proof. I'm confused.
Proof is not required, na, for exam.
Ma'am, is it the power set is actually each element the subsets are itself and
Just wait for a second. I'm switching the Wi-Fi. So then, yeah, go on now. What you're saying?
ma'am, the formula itself is saying that 2 power n, ma'am. So actually, for each element in a set A, it has a itself and null set is a subset, right, ma'am? So the formula comes from there. I think so, ma'am.
It's 2 to the power. Okay, so there are so many proofs, so you can use any of them. This is a very general proof given by permutation combination. So suppose you have a set with n elements. So let's name it to be A1, A2 up to AN. Right. So suppose you have this set which contains n elements. So then for every element, I have two choices, right? I can take this A1 or I cannot take this A1, right? In my subset, whatever subset I want to make. So that means for every element, I have two choices. So that's why the total number of subsets will be 2 into 2 into and so on into 2, and these are up to n times. So that's why this is 2 to the power. Although this is from permutation combination, there is another proof in the lecture given by sir that will use binary numbers, right? We can check that. Is this proof clear? I mean, just basic permutation combination. We have two choices.
Ma'am, I had a doubt.
Yeah.
In subsets and binary numbers.
Subsets and binary numbers. I mean that particular proof.
Yes.
Okay, so there what happens? So we somehow say that suppose you have a set A and it contains n element, then for any subset, B of A, you can assign a unique binary number. Unique n-bit binary number, not any binary number, n-bit binary number. You can assign for any subset. So that's why there is one relation between n-bit binary number and a subset. So, and we know that there are 2 to the power n bit binary number. That's why there are 2 to the power n subset. But although this proof that there are 2 to the power n bit binary number again uses permutation combination, because again for every place we have two choices, either we can enter 0 or we can enter 1. That's why we have 2 to the power n choices. So this proof and that proof is quite similar, but here we just say the notion of binary number. Okay, is that fine?
Yes, ma'am, it's clear.
Okay.
Can you describe the difference between a proper subset and just a subset?
Which subset?
Difference between a proper subset and just normal subset.
See what happened, proper subset. So what is a proper subset? So proper subset, I mean, there will be an element, suppose I say, so we can say B is a proper subset, is a proper subset of A if there is at least one A in A in such a way that this A is not in B. So that means this B should contain at least one lesser element than A. Then we can say B is a proper subset of A. And although B is a subset of A, and then B does not contain at least one element. So that subset is known to be a proper subset. Okay. So, and in general subset, it is possible that it can contain all elements. That's why we say that A is a subset of A. Right. So this is a basic notion of subset. But if someone specifically mentioned that they want a proper subset, that means they just don't want to consider A as to be its subset. Okay, every subset of A except A is a proper subset. You can say that. Yes. Anything else?
Yeah, that's it.
Ma'am, do you mean that there should be something more in A? Like B can be the proper subset of A if there is something more in A than B.
You can say that there is something more in A than B. Then it will be a proper subset.
Okay.
Ma'am, then A will be not a proper set of itself. Am I right?
You can also say that A is not a proper subset because obviously all elements are A in A, so it's not a proper subset.
Okay, ma'am. Right.
Okay, fine. So let's again I'll meet you all. So let's go to
Excuse me,
all
ma'am.
the concepts. Yes.
With the power set of null set.
Power set of null set will contain two elements. First is the null set. Suppose this is your null set, right? So the power set of null set, it will contain one element, which is the null set itself. Right. So because and also this thing is followed by the formula also 2 to the power 0, because n is the number of element, and in the empty set we don't have any number, so 2 to the power 0 is 1. So that means the power set of empty set will contain empty set only. Okay.
Ma'am, when we'll go to functions and relation, because
I'll jump to relation now. Let's go to no, but we have to do union, intersection, and Venn diagram. Venn diagram is important, so cannot skip that. So I'll do Venn diagram and then we'll go to relation, and after that power set has null set. Yeah, that's why this is an element of power set of null set. Okay, because it's a set, right? So this thing. Now let's go toward the set operations. So we have 3 to 4 set operations. Please mute yourself. So we have first operation is known to be a union. So what is a union? So suppose you have two sets A and B, then union is denoted by this symbol A union B, and it's again a set, and it will cover all the elements of A and B. So that means A union B is nothing but all elements which are in either A or B, either A or B or both. Okay, so this is known to be union. Now it is intersection. So intersection is nothing but a common element. So that means all elements which are in both A and B. So this is known to be intersection. And for union, we generally denote, we generally use the phrase and, right? So, and for intersection, for union, we say it's or, and for intersection, we use the phrase and. So that means in some question, if you find out there is some phrase is written and they join by this connection or, then it actually saying that you have to calculate union. And if there is end is written, then you can interpret that it's a intersection. Okay. Now there is one notation which is known to be set subtraction, and set subtraction is denoted by A by B. The slash is used. So it is again a set, and it will contain all elements which are in A but not in B, which are in A but not in B. Okay. Now there is one known to be a complement. So complement actually differs set by set. So suppose you have some universal set named to be U. So then the complement of A is denoted by A to the power C, and this complement is nothing but all elements of U, which are not in A. So this complement, you can assume that it's nothing but U minus A, right? Because we are containing all the elements from U which are not in A. Okay. So I'll suggest you just take your doubts, write your doubts onto some paper so that you won't forget. Okay. Now these are the basic set operation: union, intersection, and subtraction of two sets, and complement of two sets. Now there's one more main thing which is known to be the Venn diagram and the inclusion-exclusion principle. So what is a Venn diagram? So Venn diagram is nothing but a graphical method to express sets. Suppose I have a set, then I can draw a circle and I'll say that all elements, all portion within that circle will denote my particular set. So suppose I have three sets A, B, C, then and the Venn diagram of these sets is denoted by something like this. Assume these threes are circle if they draw something else. Okay. So what does this Venn diagram means? So this Venn diagram means that all portion covered within this particular circle. Those all the elements of A. So this particular region covered by the second one is the region. It's the set of elements contained in B, and this region is set of elements contained in C. Venn diagram actually help us when we want to find out intersection or union or something else. This will help you to judge what region you want to find. Right. So I'll just go by one all the regions. So this region, this shaded red one. So what does this region actually is? So this region is nothing but A intersection B, right? Because everything in this region is in A also, and everything in this region is also a part of region B. So that means this red shaded region will denote the region of AB, right? Now this yellow shaded region, this region will denote A intersection C. Because of the same reason, everything which are in this region is also a part of region A and part of region C. And this green color region, this is a region of C intersection B. Okay. And at the end, this whole intersection region. So if you observe this region, then what happens? Any element of this particular region is a part of. Sorry. So this glittered one. Okay. So any element which lie in this region is also an element of A, an element of B, an element of C. No voice. Hello, am I audible? Okay, fine. So this glitter one is actually a region denoted by A intersection B intersection C. Okay. And the whole region covered by all the three circles, this whole yellow region, this region is nothing but A union B union C, right? So you have to understand the Venn diagram very well so that you can easily answer the questions. Okay. So from this Venn diagram, there's one famous formula is known to be the principle of inclusion-exclusion is given to us, and that formula says that if you want to find out the cardinality, and what is a cardinality? Cardinality is nothing but the number of element in any set. Okay. So cardinality is nothing but number of element. I think you guys are familiar. So using this Venn diagram, there is one famous formula. It says that the cardinality of A union B union C is nothing but you have to add all the cardinalities of sets. That means cardinality of A plus cardinality of B, cardinality of C. Then subtract A intersection B B intersection C, and C intersection A, and then add the whole intersection, A intersection B intersection C. Okay, so I'll give you as a task that why this formula is true. You can judge via this Venn diagram. So just what you can do, just add one plus here if you count this region. So since I am counting first cardinality of A plus cardinality of B plus cardinality of C, so that means there will be one plus here, one plus here, one plus here. So that means if I am giving plus here, that means this region is also counted. Now this region counted twice, this region counted twice, and this region counted twice, and this region will count it thrice. Okay, so you use this particular method for showing that this formula is particular true. So I'll give you as a homework or as an exercise. Although if you don't want to do, but just remember this formula. It's a pretty important formula. Okay, fine. And try to observe how it actually derived using the Venn diagram. Okay. Now let's go toward the Cartesian product. So what is a Cartesian product? So suppose you have two sets A and B. So these are your sets. Then the Cartesian product of AB is nothing but again a set of all tuples A comma B, where your A belongs to A and B belongs to B. So this is known to be a Cartesian. And the cardinality of A cross B is nothing but the cardinality of A multiplied with cardinality of B. Cardinality means number of element in a set. Okay. So this is known to be a Cartesian product. It's a very easy concept, right? You just have to take all the elements from A and B and just pair it up, right? Now, what is a relation? So what is a relation? So very basic definition of relation is if you take any subset of A cross B, that will be your relation. It's a mathematical definition. Okay. So what does math people say? They say that a relation is nothing but any subset of A cross B. So if you take any subset of A cross B, that will be a relation. And relation is not limited using two sets or three sets. You can take as much sets you want, and you can take any subset of that particular Cartesian product, and you can define relation easily. Okay. So relation is what? Any subset of A cross B is a relation. So for example, if I have a set A to be, I'm taking a very simple example, 1, 2, 3, 4, and B to be A, B, C. I'll address all the technical doubt at the end so that I can note down your email IDs and inform further. I mean, support team, right? Okay. So if you take a subset of A cross B to be simply 1 comma A, 2 comma B, and 3 comma C, right? So then this R is a subset of A cross B. So that's why it's a relation. So it is a relation. So that means if you take any subset of A cross B, that will be your relation, no matter what subset you want to take. If you take empty set, I mean, if you take, that means if you take only just one element, 1 comma A, then this is also a relation. Okay. Now there is one terminology in relation. So suppose you have a relation. Now I think relation is clear. Relation is nothing but any subset of A cross. So suppose R is a relation on A. So we say R is a relation on A means R is a subset of A cross A. When we say a relation on a set means it's a subset of A cross A. We are taking the same set. So we say R is a relation on A, and we say two elements A and B are related, and A and B are related by R. So we say that A and B are related by R means that means this tuple A comma B is an element of the set R. So again, R is our set. So if you take any element from that set, that those two particular element A and B will be related. And this thing you can describe for any relation defined on A cross B also. So we say any two element A is related to B or A is related to B. These two symbols are usually used for saying that A is related to B. So we say that A is related to B if the tuple A comma B is an element of our set R. Okay. Now from by relation, any relation we can graph it out. So for example, if you take a relation on, suppose R is a relation on natural number cross natural number, right? So any relation over natural number cross natural number or real number cross real number, you can graph it out, right? So you'll just make your grids over rational numbers. So 1, 2, 3, and so on. Similarly, 1, 2, 3, and so on. Right. And whatever elements are there in it, you just place a knot there or a vertex or a point there. And this picture actually denote your relation. So that means it is possible to graph a relation over natural number cross natural number or real number cross a real number or rational number. I mean, whatever elements you can denote over the real line, that thing you can easily say that a relation is graphable. Okay. So I am telling that because we use this particular notion only to define that every function is graphable. I mean, if you have a function from real number to real number, then you can plot that function's graph via this the same thing, that every element a comma b will denote your function. Okay. Now, here comes the very important topic, which is known to be the properties of relation or types of relation. So first thing is a relation is reflexive. So suppose you have a relation R on a set A, then we say that R is reflexive if A comma A belongs to R for all A belongs to A. Okay. So we say a relation is reflexive if A comma, and the null set is subset of R. Yeah, null set is obviously subset of R. Phi is a subset of R, right? But for element, we want element, right? Okay. For this particular topic, I'm unmuting you because these three definitions you have to be thorough, because what happened at the end, you'll get confused. So that's why I'll just define three definitions: reflexive, symmetric, and transitive. And after that, I'll take your doubts over these three particular points. Okay. And I'll give you two examples and I'll ask you to solve it. Okay. So first thing is reflexive. So what is a reflexive relation? So a relation is reflexive if A comma A belongs to R for all A belongs to A. So if this statement is positive, that if A comma A belongs to R for all A belongs to A, then you can say that the relation R is reflexive. Second thing is symmetric. So what is a symmetric relation? So we say that a relation on a set A cross B is symmetric, A cross B, or you can take A cross A also. That's also fine. So we say a relation on A cross A is symmetric if A comma B belongs to R should imply B comma A belongs to R. Right? So here observe that this is your hypothesis. That if you want to say that a relation is symmetric, that means A comma B should belongs to R, and then you have to check that whether B comma A is belonging to R or not. Okay, if not, then you cannot say it's a reflexive or not reflexive. This imply sign is important. Okay. Then B comma A should belongs to R. So if this statement is true, then you say that your relation is symmetric. And the third one is transitive relation. Transitive means a relation on a set A cross B or B A cross A is transitive if A comma B and B comma C belongs to R will imply A comma C belongs to R. Here also, this is your hypothesis. So if you want to check transitivity, this hypothesis should be satisfied first. I mean, before you want to check it, first you have to find out two tuples which satisfy this condition, that A comma B belongs to A comma B and B comma C belongs to R. And after that only you have to check this condition. Again, this imply sign is important here. Because what happened in certain relation, hypothesis is not there. I mean, you cannot find any such two tuples, A comma B and B comma C. Then that relation is vacuously transitive because it is not what you can say countering our definition. So that's why that particular relation is vacuously transitive or vacuously symmetric, we say. So I'll give you one example. First, I'll start with the basic example. So is there any doubt in over these three definitions?
Ma'am, can you please explain reflexive
Excuse
again?
me, ma'am.
Ma'am, reflexive, please, one more time.
Yeah, reflexive. Okay, fine. Yes, someone was saying something. Any other doubt?
Ma'am, hello?
Yes.
Ma'am, all these things has already been given in the textbook given by IIT Madras, no?
All these things are given in where?
In the textbook which is provided by IIT Madras. the reflexive
Textbook.
symmetric relation, or
I
we have
think it's
to
given in that textbook. Yeah.
yes, or
Huh.
we have to study from NCERT or from this book.
No. It's given in the textbooks, although,
Hmm.
I mean, you can download. I'll share these notes also. So you don't have to worry.
Where is the
No,
textbook
I have
given?
I have the book.
Okay. Fine.
Where is the
Yeah.
textbook given?
Ma'am, does IIT Madras also give books? Like I didn't know that.
I think there is one book given by. I mean, you are talking about the reference book, right? Whatever professor have mentioned for in the overview lecture.
Yes, ma'am. Yes, ma'am.
So in that book, you will, yeah, it will be there. There is one reference book. In that reference book, you can find out everything.
We don't know the
Whatever
reference.
covered.
The reference
but-
link is not working.
Oh,
But,
reference link is not working, but you can Google it. That book is pretty common. So
hello, ma'am.
yes.
But all the things that has been covered in the recorded lectures given by the professor on our portal, the entire thing is not in the book. So the book is like a NCERT which have some data, but this is not complete enough.
So it's a reference book. That's why it's not complete because we are teaching from. I mean, we are also gathering notes from this so many books, right? So the notes won't be. I mean, the entire thing won't be there. It's a reference book. You will find out some topics there. For some other topic, you have to go to some other reference book.
So
There
we
are
have
two
to go
reference
through.
books.
So we have to go through the notes multiple time or through.
No. You just see here the definitions are clear, right? So first you have to understand the definition and then attempt the question. Your practice is more important. Yeah.
Ignacio is the author of that book.
Author of the book, actually, I don't remember now. You can find it on the overview lecture of our course.
Ma'am, please reflexive now. Ma'am, reflexive, please.
Yeah, sure. So what happened? Reflexive relation.
Ma'am.
It says that A comma A should belongs to R for all A belongs to A. That means for please mute yourself. Okay, so what happened? Every element should be related to itself. Then only that relation is known to be reflexive relation. For example, if you give you a set A to be 1, 2, 3, and if I'll give you the relation R to be this relation, that 1 comma 1, 2 comma 3, then is this a reflexive relation?
No.
What do you think? No, right? Because 2 is not related to 2, 3 is not related to 3. I mean, there are so many missing elements here, right? 2 comma 2 is not there, right? 3 comma 3 is not there. So that's why it's not a reflexive relation. Reflexive says that every element should be related to itself. That's why whenever we ask about reflexive relation, then it's on the same set A, because we want to talk about A comma A belongs to R, right? Every element should be related
This
to
will
itself.
be transitive, right?
So see, that's the thing I'm saying here, that since you don't have any type of tuple which will contradict your statement, that means we are not able to find A comma B and B comma C type of thing here, right? We cannot find A comma B and B comma C type of thing, right? Because we just have two elements, and this B is common. I mean, this B is there in very specific positions, right? So this thing is not there, so that means it's vacuously transitive. Since it's not contradicting our definition,
Ma'am,
that means it's vacuously
excuse
transitive.
me.
Yes.
Ma'am, if we have A cross B, two sets R on A cross B.
Two sets also, you have to check the same thing. For example, if I take A to B again 1, 2, 3 and ABC, if I take these two sets also, let's take this to be 3, 4, 1. Okay. And if I give you the relation R to be, here I don't ask about reflexivity, right? Because
Ma'am, please
the
disable
elements are
the.
different.
Ma'am, please disable the chat section. Everyone is spamming there.
Okay, I'll disable it. No. Okay, so I'll just do it with the host and co-host thing. Then it will be fine for me also. Now your all chat will come directly to me.
Ma'am?
Yes.
There is one question in practice assessment. Can you please solve that for us as an example?
Actually, I mean, for these things, practice assignment activity, there is one particular dedicated 2 hours for that. So you can ask that, this doubt there. Because since I also don't have time though.
So, ma'am, only between quiz 1 and 2, only one quiz will be counted for the graded for CGPA. with the end term?
No, there are two formulas. That formulas you can see. I'll project that formula at the end. I have that formula. There you see there are two sections. In one section, what happened? They will take best of quiz 1, quiz 2, or in the another section, they will just take some portion from quiz 1, some portion from quiz 2. So that's the thing. And they will just max it out. So let's go here. Yes.
What's the difference between identity and reflexivity?
Yeah, I'll come to that. Identity reflexivity. Yes, something else? Anything else?
Is there a negative also evaluation in the quiz one?
No, there's no evaluation. I'll just say that just asked out based on these three concepts. Otherwise, we'll lose our time and we won't get, because these concepts, what happened at the end of the 12 week also, students have doubt in reflexivity, symmetricity, and transitive. And I don't want that now. So I hope, I mean, the questions will be there in every quiz. You will find out in every quiz, there will be one question based on the thing that tell us this is a reflexive relation or not, tell us this is a transitive relation or not. So it's better you learn now. So if you have any doubt in these things, then only ask. Although I'll take all doubts at the end.
Concept is clear, but the thing is application where you require critical thinking. That is getting coming little difficult.
So that will come only by the practice, right? That thing I can't do anything, right? You have to think, you have to go through the question
Excuse
and learn by your, yes.
Ma'am, I have a doubt actually. So for symmetric relation,
For symmetric?
yes, ma'am.
Your voice is breaking.
So, ma'am, for the symmetric relation, does it applies for each and every element in the thing, or only
No,
for some?
again, see, if there are tuples of this form A comma B, then only you have to check B comma is there or not. I'll tell you, suppose I'll take this relation R to B, I'll just take one element here, 1 comma out. Okay. So now what you can think about this relation? Is this reflexive? Is this transitive or not? Sorry, not reflexive, since I'm taking the different sets although. So is this symmetric or not? What you can say?
Yes,
It,
Yes,
it will be
symmetric.
symmetric, right? Because we don't have anything which can contradict our definition, right? If I want to say that this statement is not true, if I want to say this is not true, so that means I have to find out one example which says that, okay, AB is there, but B is not there. So in this example, if I replace this 1 by 3, now what you can say, is this symmetric or not? Suppose I replace this by 3.
No.
No.
No, right? It is not symmetric because 1 comma 3 is there, but 3 comma 1 is not
there.
right? So that means it is contradicting my definition. So that's why it's not a symmetric. But is it transitive?
Yes, ma'am.
Yes, ma'am.
Yes.
No, it is
Yes,
not
it is.
transitive
Why it is not transitive?
because you have only one element, right? One pair, which is 1 comma
So
3.
that's the thing. We
But
don't
the cycle doesn't
require
start.
we don't require two tuples. We don't require tuples which can satisfy our hypothesis. Okay, suppose this is not there. I mean, your assumption is not there, then why do you have to check the conclusion, right? If AB and BC is not there, then there's no point of saying that AC is there, right? It is vacuously true.
Once again, could you repeat this example?
Yeah, so yes, go on.
But this is the matrix after the Cartesian product.
See, transitivity is little bit confusing that why is this happening, but see, again, my definition, what does it say? It says something is happening and based on that something we have to derive some conclusion. But the basic hypothesis is not there, something which is generating my conclusion is not there, then I cannot say that the process is true or not true, or the process is false, right? So that's why our hypothesis is not there. That's why we cannot say that the conclusion is false. Here, what happened? We cannot find out two tuples. So that's why it's vacuously transitive.
So basically, we don't have any contradictory evidence.
We don't have any that's why I'm saying that we don't have any contradictory example, or we don't have any contradictory tuple which says that it is not transitive. Now, for example,
1 comma 1 should have been there in this thing.
No. I change it to be 1 comma 3. Now, if I do this thing, if I again change my R to be 1 comma 3, and I'll say, okay, now 3 comma 4 is there. Okay. Now, what can you say about symmetricity and transitivity? Is this new R?
Symmetric, not transitive.
Not there.
Either symmetric, not transitive.
Both are not there.
Madam, I shared the textbook data. So could you please explain in this example? So because it's confusing actually. I shared
Where
an
is
image.
your image? Sorry, I'm not able to get that image. Can you share now? I think it will go up.
Yeah, I'm sharing now also.
Ma'am, this is neither symmetric nor transitive.
I shared.
Correct.
Ma'am, can you give examples to all this?
Activity and practice assignments contains, I think, pretty much examples. Just go with those examples. I'm not getting it. Who's sharing?
Now
I
also I
don't think
pasted.
What is the name of
pasted.
what is the name of the book?
Just say one, just tell one by one.
Ma'am, for checking the transitivity, we have to check only in R or things we have to hold A and B.
No, only for R. R is given to you, and then they will ask you about transitivity. Okay, let me take one example. Yes, yes.
Ma'am, so symmetry.
Please give the example for symmetric, ma'am.
So we have to prove the transitivity. We have need at least 3 elements, ma'am. Why should you?
We need at least 3 elements for saying no. We don't need 3. We just need 2 elements. This tuple we need. If I want to check transitivity, A, B, and B, C. If this type of thing is there, then you have to check transitivity. Otherwise, you can say that vacuously transitive.
Ma'am, how is it, madam? 1, 3 is transitive.
So now it won't be transitive, right? Not transitive.
Ma'am, if there 1, and 3, also exist, it will be reflexive, symmetric, transitive all. Is it?
We cannot say
4
reflexivity
should be
because B is something else, right? B is not A. When we say A cross B, when we have A cross B type of thing, then we cannot talk about reflexivity in general. See, we just say transitivity and symmetry. Reflexivity, I need A cross A. I mean, I need relation based on A cross A. So yeah, if you say that here your R2 will be, suppose this is your R2, 1, 3 and 3, 3, right? Then this will be symmetric as well as transitive, right?
Ma'am,
Because
3,
here 2
1
tuples
should
is there.
also be there, no? For being symmetric.
No. Why? Yeah, sorry. 3, 1 should be there. Now it will be symmetric and transitive, right?
Yes,
I just missed.
And ma'am,
Thank
1, 1 for being transitive. 1, 3, 3, 1, 1, 1 should
now
also
1, 1 should be there also. Okay. Now anything else we required? Because
That example I pasted, madam. So can you please explain? So it will be helpful for all actually.
Actually, I'm not getting. You can verbally tell, na sir. I'll just write it down.
Okay, I'll read, madam. So here they provided. Let R be the binary relation on set S. Okay, then R is said to be symmetric if and only if for every x comma y belongs to R, implies y comma x belongs to R, where x comma y belongs to S.
So it's the same thing, na?
Then set S is equal to 1, 2, 3, 4.
Okay.
Then R1 equal to 1 comma 2, 2 comma 1, 3 comma 4, 4 comma 3,
4 comma 3,
and 2 comma 2.
2 comma 2.
Then R2, then R2.
Okay.
1 comma 2, 2 comma 3,
okay,
2 comma 1, 3 comma 2,
3 comma 2,
4 comma 3,
okay,
and 3 comma 4. Then R3.
Okay, then R3. Okay, let's observe these two only, right? R3 will be similar to kind of thing, right?
Maybe that only confusing, madam. That only.
Okay,
can
R3 is confusing.
As
Okay, yeah,
2,
fine.
2 comma 1, 1 comma 2, 3 comma 4, 2 comma 4,
okay,
4 comma 2.
Okay.
So here they given the answer. Here R1, R2 are symmetric relation, but R3 is not symmetric relation because 3 by 4 belongs to R3, but
Right.
4 by 3 not belongs to
3
R3.
is not there. Right, correct. So it's not symmetric. So R3 is not symmetric. So what's your doubt?
Here more relations they're forming. That's why I'm confused actually. So why are the R1, R2, R3 is coming?
See, okay, so you guys can answer now. What about R1? What do you guys think? What about, I'll ask three of them: reflexivity, symmetricity, transitivity. Is this reflexive?
No, ma'am.
No, ma'am.
No, ma'am.
Is this symmetric?
No, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Is this transitive?
No,
There is
ma'am.
a 2,
No, ma'am.
4. There's a,
No.
I
Right?
think it
1,
is a
2 is
reflexive,
there,
ma'am.
2,
No, ma'am.
no, it's
Hello?
not reflexive, right? We want
Madam,
all the tuples should be related, not 1 or 2 or something. Only 2, 2
R1
is
is
there.
the transitive, right, ma'am?
Sorry, it is transitive, na? I mean, yeah, it is not transitive, obviously,
Ma'am,
because
3,
1,
3 is
2 is
not there,
there
so
and 2,
not
1 is
transitive.
there. Ha.
Ma'am,
So
2, 2 is there now, madam. I think it's reflexive.
no. Reflexivity needs for all element, not one
For all
element.
elements of the
For
set.
all element, it's only 2, 2. I need
So
1, 1 also, 3, 3 also, 4, 4 also.
so all one that say 1, 2, 3 for all should have the reflective, right?
Right.
Okay.
Yes.
Every element should be related to itself. That's what reflexivity says.
Ma'am, suppose if the R1 contains 1, 1, 2, 2, and 3, 3, then can we call it as an identity?
No, see, identity relation is what? So identity relation only contain the identity tuple. Matlab, identity relation is what? If it contains 1, 1, 2, 2, 3, 3, and 4, 4. This is the identity relation. It won't contain any other element. But what reflexive relation can do? Reflexive relation can contain other tuples also. For example, 3, 4, 4, 3. I mean, all those tuples can be there in reflexive relation. But identity relation specifically mention that it wants only the same tuple. I mean, A, A type. That's the
Ma'am,
identity
can I
relation.
get an explanation for why R1 is not a transitive?
See, here 1, 2 is there, 2, 1 is there. So that
1,
means A,
1.
B and B, C is there. But 1, 1 is not there. Na? 1, 1 is
3,
not an
3
element
also.
of. Same thing 3, 3 is not there. I mean, we are forming, we can get in contradictory pairs, right? So that's why it's not transitive.
Okay.
Is that fine?
One is there means
Yes,
we
ma'am.
can
Thank you.
Right. See, A, B is there, B, C is there. So A, C should be there. Then only you can say it is transitive. Otherwise, you can. Okay. Let's quickly check what about R2. R2 is reflexive. Is R2 is reflexive?
No, ma'am.
No, ma'am.
Is it symmetric?
Symmetric.
Yes,
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
It is symmetric, right?
Symmetry.
Is it transitive?
No, ma'am.
No, ma'am.
No.
What about R3? R3 is reflexive?
No.
No, ma'am.
No, ma'am.
It is not symmetric, right? Because 3, 4 is there, 4, 3 is not there. So that's
Ma'am,
symmetric.
R2, why it is not transitive? We have 1, 2, 2, 3, and 3, 4 is also there.
1,
So which
2
means
is
1,
there,
4.
2, 3 is there,
1,
but
3 is
1,
not there.
3 is not there. Na? For every double, I want A, C is there.
Even 1, 1 is not there.
Even 1, 1 is not there. See, 1, 2 is there, 2,
So which
3
means
is there.
that if a set need to be transitive, then we are expecting A, B, B, C, and A, C also should be there. Okay.
Okay. And the other thing is, if you can't find A, B and B, C type of thing, then you can vacuously say, okay, this relation is transitive. That's all. That's a one thing, because this situation happen in so many places and the student will miss the transitivity.
Can you give me this type of one example where we cannot find any?
Just take one element, ma'am.
Yeah, I mean, you can take one element. For example, if you take the relation R to B, simply 1, 1. Then now you guys answer, is this a reflexive relation or not?
Yes.
No, ma'am. No, ma'am, because all the elements are equal.
Yes. Symmetric also.
It is reflexive.
Are you guys, what is reflexive relation? Reflexive relation says every
Why
element
is
should be
R3 not
related to
symmetric?
itself. R3 is not symmetric because this of 3, 4. 3, 4 is there, 4, 3 is not. Your voice is fluctuating. See, reflexive says all element. I'm specifically emphasizing on all. This is containing only one element, 1, 1. How this can be reflexive? Now you
Not
guys.
reflexive.
It is not reflexive, right? Your set contains 4 element, 1, 2, 3, 4. If I want
But why is
reflexive relation, every element should be related to itself. This all is there in reflexive.
Okay, madam, understood.
why is not
I have a
Understood?
small doubt. Can I ask?
Yeah.
If
Just
R
go one by one.
R is
Huh.
having a pairs 1, 2 and 3, 4, is it transitive? Can we say
One, what you're saying? 1, comma?
one pair is 1, 2 and other pair is 3, 4?
What you can say? Just
We
observe
say
it.
it is transitive.
I'm asking you what up to till we discuss. So what you can
I
say? Is
think
it transitive or not?
because it doesn't have the void relation you were telling.
Correct, correct.
Doesn't start
So
data
it is not, sorry, it is transitive because we cannot find out any contradict pair.
Okay, ma'am.
A comma B and B. That's right. Okay. Is that fine?
Ma'am, why is
Can
RS
you
not
explain
symmetric?
once more, ma'am?
Ma'am, can
I
we move
didn't get it.
forward?
Ma'am, please.
Can you explain this once more?
Ma'am, why is
1,
RT
3,
not
4?
Ma'am, for transitive also, like reflexive, should it satisfy all the elements? Example one, if a
Yeah.
set contain 1, 2, 3, 4, it should have
1, 1, 2, 2,
2.
3, 3, 4, 4. All
No,
double should be there.
not for reflexive, for transitive I'm asking. Like if
No,
there are 4 elements.
transitive, we only check on the relation.
Only
See,
the relation.
only the relation. Reflexivity needs all. That's all.
But for others we
we
doesn't
don't
need, right?
Correct, correct.
Okay, thanks.
Reflexivity
the last
says
example,
that every
how?
element should be there. Yes, last example, how, Lokesh?
How it will be transitive, ma'am? Can you explain once more? I didn't get it.
See, again, I'm saying that transitivity, what does it say? Transitivity says if this if is there, right? If A comma B and B comma C is there, then you have to say A comma C is there. But this if is not satisfied, how can you say that your conclusion is wrong? I mean, if something, suppose you don't plant a tree, then how can you say that this is a mango tree or a banana tree or something else, right? We don't know anything about that, right? So this if condition we required if you want to say it is not transitive, right? If this if condition is not there, we vacuously say that it is a transitive relation. That means, I'll repeat, suppose, so this thing you can remember that if you cannot find any pairs, any pair A comma B and B comma C in such a way
So the
that A comma
example
C is not there.
is symmetric first, ma'am.
Keep silent, यार.
Sorry,
मुझे
example.
देखने तो दो यार.
Exam से भाई. Easy. Hello? Yeah, someone was saying something.
Ma'am, the previous example, it can become a symmetric also, right, ma'am? 1, 2 and 3, 4.
No, it's not symmetric because
4,
2, 1 is
3
there
and 2,
na.
1.
So there are so many doubles are missing. Okay. So see, I think we have plenty of discussion over the symmetric. I'll just give you some time. Just sit and mug up the at least
Just a
definitions.
question.
Yes,
Ma'am,
Amritanshu.
is identity relation reflexive?
You guys can answer.
Yes.
Suppose I have the identity relation.
Yes,
1,
it's
1,
only reflexive.
whatever relation. I mean,
It's
all the tuples.
reflexive and symmetric.
So, is this reflexive?
Transitive also.
Yes, ma'am.
Why? I'll ask you why it is reflexive.
All
Amritanshu,
these
you can answer.
tuples are present.
Just, give me a second. Amritanshu, you can answer about reflexivity.
Ma'am, it is reflexive because every element is related to itself. 1 is related to 1, 2 is related to 2, like that.
Correct. Now,
And
Roshni, you will tell, is it symmetric or not?
Ma'am,
Hello?
it is a symmetric, ma'am.
Why it is symmetric?
Because 1, 1 is there and another thing is A, B and B, A. So it is symmetric actually.
Correct. Because here what is happening? A
One-
and B are same thing. I mean, 1, 1 is there, 2, 2 is there. So here A and B are actually same. That's why it is symmetric. So that means every tuple is satisfying. If A, B is there, B, is also there. So that's why it's symmetric. Now, Lokesh, you can answer about transitivity. Is this transitive?
No, madam. Exactly no.
No, ma'am.
Why it is not
transitive, man.
It is
Because
transitive.
pair doesn't start.
Just wait
Ma'am,
a
it is
second.
transitive.
Wait a second. Wait a second. Lokesh, you can judge. Say whatever you are observing. I'm not saying that you're wrong or something. Why you think that this relation is not transitive?
Get it maybe not transitive because there is a 1 comma 1, but nothing element which starts from 1. There is no element, ma'am. And exactly I was telling you there is 1 comma 1, but there is no anything 1 comma anything.
See,
just
that's
like
the
1
thing. Now
comma 2.
you are not able to find these two type of tuple. You cannot find A comma B and B comma C. So when you can't find A comma B, B comma C, then you can immediately say it is transitive. You don't have to think about it.
That's what
So
I'm
it is
saying.
a transitive
Why is
relation.
it symmetric? Why is it symmetric?
Okay. So why is it symmetric? You can answer. What is the
Reverse
definition of
elements
symmetricity?
are present. 1 1, then 1 1.
1 1
If
is
you do
there, 2 2 is
reverse,
there. So it will become 1 1 again. So that element is already there. We don't need 1 comma. Again, the set don't need duplicacy, right? You guys are familiar with that. So if I write a set which is of the form 1 1 2 3, so this set is same as this set 1 2 3. The set don't allow duplicate element. I mean, it treated to be a one element only. So that's why this identity relation is symmetric relation, because 1 comma 1 is there. If you reverse it, it will again become 1 comma 1. So 1 comma 1 is there, right? Is that fine for everyone?
Ma'am,
By
I didn't
reversing
get.
it,
Okay, wait. Ma'am, I didn't get the part where you said that a relation with only one pair, one couple inside, which is one is related to one, only one couple inside that relation. It is
Yeah,
not
correct.
reflexive. Why?
No, correct. In reflexivity, we need all element. All element of A
Ma'am,
should be related to it.
see, this relation have one element only, one unique element only. That is one, and it is related to itself. Okay.
No. For
Then
A, what does reflexivity
We
says?
need all
Definition
identity
C.
pairs.
Reflexivity says that a relation R on A means R is a subset of A cross A, right? So a relation R on A is reflexive if for all A in A, we don't need for all R in A. We need for all A in A, this pair A comma A should belongs to R. This condition we need. Here what happen if you take only one single element, then this condition is not satisfied, right? Because my A contains 3 to 4 elements, right? 1 2 3 4.
ma'am, in previous question there is a 1 comma 1, 2 comma 2 in upper, ma'am. Previous question.
This one identity?
There is a 1 comma 1, ma'am. And
This one?
This one identity, ma'am. Identity, ma'am.
Identity, okay.
Here is a 1 comma 1, ma'am. Here is a 1 comma 1, ma'am. We don't have another 1 comma 1, right, ma'am?
But we don't need another 1 comma 1 comma.
Ma'am.
Yeah. We don't need another 1 comma.
Then how would you say, ma'am?
Because see,
relation. How would you say,
relation.
ma'am? It is symmetric.
See what happened. Yeah,
How
I'm
would you
giving
say
you
it's a
explanation.
symmetric, ma'am?
Yeah, I'm giving you explanation. Just 1 second. See what happened. This is a set. Relation is a set. And in any set, we don't need duplicate element. For example, if you have a set, that particular example which explained by sir. So if you have a set which contain Kohli, Dhoni and Pujara, right? So this set is same as if you repeat Kohli. That means Kohli, Dhoni, Pujara and Kohli. Right? So that means set does not allow repetition. So these two set will be same. So that's why if you write down these all tuples twice, suppose you will write down 1 comma 1 and again 1 comma 1. 1 comma 1 is this, okay? 2 comma 2 and again 2 comma 2, right? And so on. Then this set and this set will be same. That's why we don't need 1 comma 1 twice. If we have just 1 comma 1 once, then that is sufficient for us. Why? Because in a set, duplicate element does not matter. Is that fine now?
Then number of sets will be increased, ma'am. The number of subsets is 2 power n. Then here should increase,
No.
ma'am.
Correct. Your doubt is
cardinality,
correct.
we
But
only see
again,
unique elements.
because although then this is not a set now for us. If it is a set, then I don't write 1 comma 1 twice. That's the main point in the set. We don't allow repetition.
So this kind of pairs, then all relations will satisfy, right? So all it will satisfy. Reflective, symmetry,
reflective.
transitive.
That's why identity relation is important, because identity relation is reflexive, symmetric, and transitive. And
considering
whatever
the
relation,
duplicates not a matter in the sets.
Right. Duplicate does not matter. That's why here we don't need 1, 1 twice. Because again, relation is a set.
But it is going assumption mode, no? So we're not sure it is available or duplicate or not available. How we can decide actually?
It is a set, so obviously duplicate won't be there. And we don't need duplicate even though. Because if 1, 1 is there, see 1, 1 is there. If you reflect it, that will become 1, and this is same element. It's become the same element. It's something like you guys are familiar with inverse concept. Suppose 1, 2 is there. So 1, 2 plus 1, 2 is equals to 1, right? Now, if I replace this 1, 2 by the first one, then can you say the difference? Can you tell the difference? Obviously not. So same thing is happening here. Here we don't need two pair to say that it is symmetric. We just need one pair, because this 1, 1 will give us 1, 1 belongs to R itself. Just go by the definition only. You don't need anything else. Just
Ma'am, there is a
check the
question.
definition. Yeah.
So, what is the real-time example of these relations, and where can I use this reflexive transitivity and this equivalence relations?
Yeah. See
I
what
can't see
happened.
anything.
So
it's like a theory knowledge that I'm storing in my mind.
See what happened. So
yes,
you are
proceed.
now in Maths 1 course, right? Then you will go to Maths 2 course. There you will study what we can say vector spaces, transformations, linear transformation, and so on. Then you will go to MLT. There you will study some data structure, and the particular data structure, whatever they want to make, the whole. I mean, there is so many relation which will contribute. I mean, they will work in a background for that particular data set. That means what is happening, this relation is some kind of, you can say these are the bricks of your all the data structure. If you don't know the particular, obviously, since these are very foundation things, since you guys are seeing it first time, that's why you are like that it's too tough or something, or confusing or something. Not tough, confusing, you can say. So that's why it's confusing. But although
So
if
it's
you
like
get
just
handy with that,
memorizing and by hearting it for the getting the marks. There is
no,
use
it's
use
not
of
that.
it, right?
No, it's not like that. Equivalence relation is useful in every term. That's why here
sorry to interrupt,
teaching you
ma'am.
in the first. Okay, yes, go on.
I just wanted to extend what you were telling. Please let me know if it is correct. So far, we are looking at the pairs theoretically, but there are certain operations. To give an example, for symmetric, which is A plus B is equal to B plus A, right? Here the relation is, we can say,
addition, right?
Symmetric. Yes, right. So that is an example. And for transitive, A is greater than B and B is greater than C, then A is greater than C. That is transitive. So we can form pairs like that and say, and those are the real-time examples that someone were asking for.
Right. Yes, go
Right.
on, Raghu.
Yeah, but one thing I couldn't correlate is the first property, which is
reflexivity.
I am trying to pull out an example for that, but I couldn't.
Multiplication, you can say. No, not multiplication, although there is one by zero it is there, but although reflexivity you cannot multiply.
Ma'am, can I join if there are two brothers, one is brother to another and another also brother to another?
This relation you can say reflect. No.
Ma'am, one line is parallel to another.
For reflexive relations,
a person is related to
addition is although
Ma'am, take your time. Next class I'll ask the same question.
You can take divisibility, not multiplication, but divisibility you can take. Division operation will give you reflexive. As A is divided by itself. Right? I mean, mathematically I'm saying.
Can take an example of reflective.
Yeah, so see, there are so many examples. You can go through any book, or we also have if you go through the previous term question papers, you will find out plenty relations there. But the main point is this concept is important. Why it is important? Because it's a base of your whatever you are going to study further. If you don't know these things, you will face so much problem there. That's why I'm saying that. That's why Maths 1 is a foundation course. It's your foundation. If you are able to think mathematically, you can easily tackle all the algorithmal or all the problems whatever come next to you. And although this relation actually, see what happen if you have any relation over any set, then it will actually nicely partition your set. It will give us one chamber type of thing. So in that thing, it's very easy to compute something or do something on that particular structure. So for now, time being, just just now you can say if you want to mug up
That's
or
what I'm saying.
just mug up or not, it's up to you. But I'm just saying that concept is important. That's all.
Can you give summary for all types?
Yeah, so I'll just summarize it, and with this, we'll end our
session. Ma'am, a slight doubt I have.
Yes.
Ma'am?
Yeah, Radhika.
Ma'am, if I have AB and BA, then it is a transitive, right?
AB and BA, but you need A comma A then, na? Because AB
yes,
is
ma'am,
there.
like A comma B and B comma A. Then is it a transitive, or if there is no C, then it is?
No. You need A comma A then. Because here AB is there, BA is there, so A comma A should be there, right? Because here your C is A, so A comma A should be there. Then only you can say it is transitive.
Thank you, ma'am.
Okay. So reflexivity. So suppose R is a relation on a set A, then R is said to be reflexive if A comma A belongs to R for all A belongs to A. So here this for all is important, and for all A belongs to it. Okay. The second thing is symmetric. There is one more type, anti-symmetric, but symmetric relation. So we say R is symmetric if A comma B belongs to R will imply B comma A belongs to R. Okay. So if this statement is true, this implication is true, and if you can find out such a tuple A comma B, then you have to check your thing, and then check this particular statement. You can say it is symmetric. And transitive, as R is said to be transitive if A comma B belongs to R and B comma C belongs to R will imply A comma C belongs to R. Again, if the hypothesis is not there, then you can vacuously say that your relation is transitive. Hello, am I audible?
Hello.
Yeah.
Yes, ma'am.
Sorry again.
Yes,
What?
ma'am. Yes, ma'am.
Can't see.
But you're not visible. Okay.
You're not audible.
For
right
hello?
now, okay, yes, fine.
Okay.
Fine.
Yeah, someone asking about books. So I think they have given Thomas Calculus by Pearson's publication. I'll check. I haven't
Thomas?
gone through the overview.
Which one?
Thomas Calculus is there, right? It's a very
Thomas
famous book on calculus. Thomas Calculus.
Okay. Thank you.
That that book contains.
Ma'am, tomorrow morning there is a session.
Yeah, I'll just end here.
Is it an extension of this? Or,
sorry, what? Tomorrow morning is there for
yeah,
Maths 1?
10 a.m. to 12 p.m. by. Is it by TAs?
It's a TA session.
That is
TA session is there. Fine. Sorry.
What's the difference,
ma'am? In next class, you will summarize function.
I'll continue whatever left over is there. Functions, and then because this is, see what happened at the end also I heard from some of the students that they have confusion reflexivity, symmetricity, transitivity, and I don't want that now in this term. So is these three things is clear to you? If not, then yeah, we can discuss this to some other session or some revision sessions, because I think I should give you some time to sit and think about it. Okay.
A small doubt for transitive. An example: if a comma b and c comma a is there, then it is tranquilly transitive, right? A comma b and c comma a.
Yeah, correct. A comma C and C comma A is there. Yeah, correct. It is vacuous. Now it is no. Again, you need A comma A, na?
No. A comma b.
A comma B and C comma is there. Yeah, now it is vacuously transitive. Correct.
And if there is additionally the a comma and a, even then it is transitive. Right?
Even then also it is transitive. Right.
Yes, until the cycle start.
Okay.
No, ma'am. Is it fine?
No, it is not transitive.
Because the second and third, I think we have
C comma A and A comma
It's
C
transitive.
is there. It is transitive, na? C comma A comma C. So C comma A is the C comma A only. You don't need an extra pair.
But it
You
is
can treat
not
the same
symmetric.
mode.
But it is not symmetric.
Yeah, it is not symmetric,
Yeah.
correct? Because
Ma'am,
B comma
in
is not
the
there.
final conclusion,
C
in the
comma
final
is not there, ma'am.
conclusion,
I think it is not transitive.
C comma A, it is something like A B, and the third one is like B B C, right? The last the second and third.
AC.
So
CA and A.
yeah, CB is not there, na? I mean C comma A is there and A comma B is there. So it should imply that C comma B should be there. But here C comma B is not there, so it is not transitive. That's why I'm thinking something. Not transitive.
It's not
Yeah.
transitive. Okay.
Correct.
Thank you.
Just try it out. Couple of example or
Is not there.
should
C
try
comma A
it. We
is
should
there,
try
A comma
it.
is there, and CA is not.
Yeah, that is also right. Yeah, that is also right.
We should
CA
try
is there.
easy. Just one by one.
Is there also when you said that line, if there is the note is like if is there, so it is automatically you said transitive.
If you cannot find out such a pair, then it is automatically vacuously you can say it as transitive. Same thing goes with symmetricity. Yes, Deva.
It is transitive, no, ma'am.
This are?
Yeah.
But we are finding a counter pair, na? A comma C comma is there, A comma B is there, but
Not
C
transitive.
comma B is not there. So that's why it is not transitive. I'm finding a contradict pair.
Okay.
Yeah.
Ma'am, B comma is also not there.
No. Ma'am, this first are A, B, C, A, and A. It is not transitive.
It is not transitive. Yes, it is not
Why?
transitive.
It is like A, B is there. Okay, I am taking the first element A, B. So I'm searching over there. B comma B starting with nothing is there. Okay. Then I want to leave that one, right? So C comma A is there. I want to search A. So A is there. A comma A is there. So again C and A is there again.
C comma
So
is
that
there.
is
So
okay. That
it's
condition is
satisfying. So
okay.
it won't help, right?
Okay.
Correct.
And last also A comma A is there. And A comma A is already is there. It's a transitive.
No,
A comma
but
B is also there, na?
CAAB is there. CB is not there.
C comma is there, and you can with C comma A you are taking just only one option. You have to check for every pair. C comma is there, and A comma B is also there. But
You have to
C
check
comma
all
B is
the
not.
option.
Yeah, obviously you have to
Yeah.
check all the options. That's the main definition thing, right?
Done.
Order.
Okay, see, Roshni, your voice is very,
Your voice is breaking up.
fluctuating.
Ma'am,
I'm not
when will
able
the
to
class end?
understand.
Ma'am,
Now
can you
only?
are you audible now, ma'am?
Yeah, Roshni, just go on. Quick.
Ma'am, if we say the example of A comma B and C comma D, is it transitive, ma'am?
A comma B and
C comma D, ma'am.
Yeah,
It
obviously it is
validates the
transitive.
rule. Okay, ma'am.
Ma'am, can I finally summarize all the inputs that you've given related to transitive? We can call a relation. We can call a relation of a given relation as a transitive, provided in two conditions. One, if the elements in the given relation doesn't contradict with the definition of transitions like A comma B and B comma C and C comma.
First thing is that you have to check all the pairs. If you cannot find any contradiction, then you can say it is transitive.
The second point is
huh?
if there is a if the elements in a given relation has a comma B and B comma C, but if A comma C is not there, then we are going to say that it is not transitive, because two elements of the condition of a transitive is there, but the third element required to
the third one is not there.
is
So
not
that
there,
will be
then
your contradict pair.
so which means that we can call it as a non-transitive. Either all the three pairs should be there in order to call it as a transitive, or if none of the three pairs are there, then also we can call it as a transitive.
Call it transitive, correct.
Okay, thanks a lot. This clarifies.
Ma'am.
So, yeah.
Ma'am,
Yes,
once you
Krishna.
explain the rational numbers topics.
Rational numbers, nothing. I mean, what you want to ask in rational number particular?
Rational number, factorization topic.
Characterization means?
That previous R is what kind of relation is this then? No transitive, no symmetry.
Just a relation. That's why I say mathematician says that a relation is nothing but a subset. That's all. Don't bother about it.
Subset of the Cartesian product.
Correct.
Yeah.
That's what a mathematician can say about relation.
So there is no point that it should be in particular relation. It can be any kind of set.
Any subset if you take, that will be a relation for us.
So this R won't be having any kind of relation, right? No identity, no reflexive.
No, it won't have any
nothing.
property. Just a relation, simple relation.
Got it. Got it. Thank you.
Ma'am, when will be your next Maths-1 theory session, ma'am?
I think it's on tomorrow. That will known to be a doubt session, but in the first half, I'll try to cover all the theory, all the remaining theory, and after that, I will take your doubts.
Okay.
29 is
Could you
the
show
right.
me that cardinality formula?
Yeah, that formula, na? Yes.
Excuse me, if we have to find number of relations.
No, we won't ask you about number of relation because it need more knowledge over permutation and combination. So leave out that question. Although if you are interested, you can Google it out and see. There are nice formula. There are n into something is there, n into n minus 1 by 2 type number
2
of
power
elements.
mn.
There's, I mean, for every property they have other number of relation, and there are significantly less equivalence relation, right? Okay, so this is your formula for, yeah, just go on, you can say. I'm just writing the formula.
Ma'am, is practice assignments will be graded, ma'am? Like
No,
will
no,
be
no.
considered,
Practice
ma'am?
assignment will be contain any credit for it.
Thank you.
Ma'am, I have a question.
Yes.
Today's session is a theory session, and tomorrow morning there is a session by a TA. This question might be a naive question, but I'm trying to understand because sometimes I might not be able to join a session. I want to decide which ones are useful for me. So tomorrow's session by a TA, what does that mean? Is that a doubt clearing session, or is it an explanation of a particular topic? What is that?
They will discuss about practice assignment.
I mean, whatever practice assignment is there in week 1. So a TA will choose some of the difficult or some of the critical questions, and he will discuss there. That's happen in TA section.
Okay,
So,
if the problems that have come across those exercises, if I am familiar with them and it is clear, I can skip them, is it?
obviously you can skip them because I can understand. I mean, so many sessions are there. So,
right, yeah. Okay.
When we discussed about transitive relations, we finally concluded with the two possibilities. Either there is no element which is contradicting the theory of transitivity, or if there is any elements, then the A comma B, B comma C, and A comma C should also be there. That is what we concluded. Is that similar conclusion is applicable for symmetric?
Yeah, right. Yeah. Similarly, you can address symmetricity also.
Okay.
If you cannot find any contradictory pair, you can say it is symmetric.
Okay.
Yeah.
Ma'am, is the class over?
Yes, Mahesh. What?
If a relation has 1, 2, so can we say only one pair? So can we say it is a symmetrical relation?
No, you need 2, 1.
2, 1.
AB is there. BA should be there.
Okay, only 1, 1 can be in such that case.
In only 1, 1 can
elements.
say it is the.
Okay. Yeah. Thank you.
See,
but you
now
answered him for a different question. You answered differently for his question. because he was asking if it is same like a transitive also same goes to symmetric, but you said yes, but it is not goes with yeah.
It
He
goes
was
now. I mean, for
asking whether
symmetricity has two things, but sorry, transitivity has two things, but symmetricity only have one thing. So he says that
Yeah.
if we are not able to find any contradictory pair, then we can say it is transitive. Here I am finding one contradiction. Now 1, 2 is there, but 2, 1 is not there. Right.
So
So
it
this
is
is a
transitive,
contradictory
but
pair.
what it is
So
not
it is not
symmetric.
symmetric. Yeah,
Yes,
it is
That's what
not
I'm saying.
symmetric.
I understood.
ma'am,
So
1,
you have said
1 is
yes for
not
both,
there.
so I got a doubt like that. No problem.
Okay. Okay, fine. So now, yes. Anything else about the concept?
No, this session is very helpful, ma'am. Thank you so much for being so patient and extending.
Yeah, guys. Just wait a second. Yes.
Ma'am, you can explain once again the rational number and irrational
or
number.
tomorrow, madam?
Around functions, I will cover tomorrow.
Tomorrow,
In the evening session,
Yours is
8
not
to 10.
scheduled.
Okay.
It is not scheduled. I'll just take it out tomorrow or whatever the next session is there. So I think it is on tomorrow, as I remember, but I'll check.
Tomorrow available, ma'am. Tomorrow available.
Ma'am,
Yeah. Yes, Kishan.
ma'am, you can explain the rational number and irrational number once again.
Ma'am,
Okay,
one
I'll do
one
that.
doubt there. Ma'am, this
Are you
reflective should have all the elements, right? If you have only one, it is not reflective, right?
Yeah, correct. It is not reflective. Amritanshi, yes, go on quickly.
ma'am, is more content going to be covered or is the class over?
Yeah, the class is over theoretically. I'll just take all the email IDs who are
Doubt
facing some
session.
issues, and that's all. And the doubts, whatever
Okay.
have, for 10 minutes only.
Madam, last question. The NCRT, some people are told, I don't know what is actually NCRT books, something during the.
So actually CBSE, whatever syllabus is there, so CBSE uses this NCRT book. It's a pretty standard book for mathematics, physics, and chemistry. So they have certain, I mean, they contain all the topics very nicely. So there is NCRT 11th standard book and NCRT 12th standard book. So you can go through them and check our topic. And this is a formula for evaluating final score. And here F is known to be your final exam, end term. GA means your graded assignment. Quiz 1 means quiz 1. Quiz 2 means quiz 2. Yes.
Okay.
Ma'am, once you explain the rational numbers and irrational numbers.
Yeah, I'm going to explain now only. Just I'll just give you the formula. So is this formula is clear?
Yes, ma'am.
No, not clear.
No, ma'am. Please explain it.
Ma'am, could you show me that
Ma'am, will you
coordinate
provide the spreadsheet?
Yeah, it is provided in that particular PDF. So here what is happening from your graded assignment, whatever score you will obtain over the 11th best, 11 best graded assignment, 11 or 10 is there. I'm not confirmed.
10
I think
best.
it could be okay. 10 best is there, no? Okay. So over the 10, I mean, you will submit 11 graded assignment. From that 11 graded assignment, we will take your 10 best score multiplied by 0.1, and that will be the contribution from graded assignment. And then you will get add up with this score, which is the maximum of two quantity. So first quantity is your final score multiplied by 0.6, and here all the quantities will be converted into 100, and after that they will be multiplied. Yes.
Ma'am, are you going to share this note?
Yeah, I'll share this note in chat box, but for that you have to wait at least 5 minutes. Okay. So here what happened, we have to take maximum of two things. First quantity is this quantity, that means 0.6 multiplied your n term score plus with 0.2 multiplied with maximum of quiz 1 comma quiz 2. That's why I'm saying that since here it is maximum, so what happened if someone scored out of, suppose he scored 100, he won't want to give quiz 2, or he was like he or she will like okay, just skip quiz 2 type of thing. But don't do that, because it could have, I mean, every exam will give you some experience
Ma'am,
also.
if we
So
give
that's why
quiz 2 and we get little lesser than quiz 1, then also the first formula will be considered.
Then the maximum of both two formula will be considered. See, here is also 0.4 multiplied by final score plus 0.2 multiplied by quiz 1 plus 0.3 multiplied by quiz 2. Right? So there is a little more weightage over this thing. So whatever maximum thing you will get, that will be your final.
For the Samiksha, there is this, I think you missed it. There is actually, if you say the first one, only the 90% is taken. It's 0.6 plus 0.2 plus 10. So it's only 90 out of 100, not 100 out of 100. Whereas in the second case, it will be full 100 will be taken into consideration. If somebody misses quiz 1 or quiz 2, only 90 is coming into.
But the 10 marks will be decided by GA, na? Graded assignment. This is your 10 marks?
10 of GA plus 0.6.
Plus 0.2.
Yeah. Plus
Okay, this
0.6,
is 6
that's
and
0.7,
0.2
plus
and
0.2 is
yeah.
0.9.
0.2 is
So
there.
only 90. If anybody
But
misses any of the
this
quiz,
is the
it's
only
only 90
formula
is
it's here. Yeah, I'm getting your point. But the PDF says 0.2 only. But let's see. So I think this 0.6 will help.
This is the formula. Yeah, the formula is right. But what I want to say is in the first case, only 90 marks is considered for the final evaluation. Whereas in the second case, a full 100 marks is taken into consideration.
Okay, fine. Okay, got it.
Ma'am, will you provide the spreadsheet of live lectures link?
I'll provide the what? Spreadsheet?
Spreadsheet of live lecture link.
Spreadsheet, I think they have given you via the mail. Have you got any mail?
In computational thinking class, sir has provided one spreadsheet link there.
Yeah. So in computational thinking, I think the number of people are less. Here we have at least 1,000, 2,000 people. So I don't think it is possible to. But yeah, I'll make sure to give a reminder over the team. They will send you one link. Over that link, you can go through that spreadsheet or. Although you can join via the calendar also. No? The calendar is there.
Okay, ma'am. Okay, ma'am.
Ma'am, is quiz 1 is considered as a qualifier exam?
Yes, quiz 1 is considered as a qualifier exam. Now at the end, I'll just say this email, all those email IDs, whoever facing the doubt, whoever facing the technical issue, then I'll just explain what is rational, irrational, and we can end our session because
And
it's too
please
late.
provide the notes.
Yeah, I'll share the notes.
Tomorrow 8 to 10 in the evening, right?
8 to 10 in the evening.
I am unable to get access to discussion forum and announcement group for other
Discussion
subject
forum
and announcement groups. So
other subject.
For maths, I am getting the access, but for stats and others, I just cannot.
So you can tell the stats instructor; they will inform that you are not able to get. Okay. So here one. So what's your issue, admin? Something.
How can we connect to them?
Via the live session only. They also have some live sessions.
Ma'am, to qualify, how much you will require?
For qualifier, I think 40% is required. As I know.
Today's
50%.
Yeah, today what?
Today's link for the session, I found it very. I mean, there was link not provided on my portal, madam.
Okay, so Adya, can you share your email ID?
Yeah, I've shared over the chat now.
This one, you something is there, right? Is that your email ID? Actually, it I think might go up, so you can share now so that I can take a screenshot of that.
Okay, it's showing that I'm sending it to IT Matters online degree. Yeah, no,
I'm not getting.
Via chat, no.
No, I think we can only send to you or to the IIT Madras. Only two options are there.
Okay, so send to me. Don't send to IIT Madras BST. There's one option there you can select. No, I haven't got your email ID. I got admin email ID and that's all.
And Samiksha, I have a request.
Yes.
Because we have the sessions of stat and math following one on the other. So if the stat session gets extended, it gets overlapped with the math. So could you kindly arrange to either way that there is a gap?
So stat station is from 6 to 8, right?
Yeah, you are right. So it normally gets extended sometimes. That's what I could see.
Okay, I'll ask sir. I think who will take that session? Prashant or some.
Ma'am, please provide
Yeah, I
the
got
notes.
the email ID, so now I'll just. Sorry, what?
Madam,
Ma'am,
out of
please
how many
provide
marks the
these
quiz one
notes.
can? So I guess it will take a long time.
Just I'll share the notes.
Ma'am,
About that.
actually, I'm unable to switch the subjects in a calendar, ma'am.
Okay, you are unable to switch subject. Okay, I'll mention them all the things that you are not getting the link and all. First I'll share the notes.
Someone asked for reminders. Someone asked the irrational rational. Why is waiting for a long time also?
Yeah, I'll share the first. No, I'll share the notes. Then you guys can leave. I mean, whoever don't have doubt, I'll stay here for 10 minutes. Then.
Ma'am, out of how many marks the quiz one can conducted, ma'am?
How the?
Quiz one, out of how many marks quiz one can conducted, ma'am?
Uh,
Can be.
Yeah, out of 50, you have to score something, and that score will convert it into 100.
Out of 100, ma'am?
Sorry, I was not able to access the link, so I went out.
They're all multiple choice questions only, ma'am?
Yeah, multiple choice only. No. Multiple choice, MIT, multiple
Fill in
select.
the blanks.
Filling the blanks means NIT type of questions.
Numerical type, ma'am?
Numerical type questions.
Okay.
Madam, in the course page, there is a about the course section is there. In this, there is a textbook link. It's not working, madam. So that link, is not giving there is a working in browser.
Yeah, I'll say someone to handle. Actually, some other people handle that, but yeah, I'll inform them that update that link. I think that link got expired or something.
Ma'am.
Yes, thank you.
Hello, ma'am.
Yes, Adya.
Ma'am, I'm not able to access the link of these meetings and sessions, especially these live meeting sessions. Ma'am, as your maths instructor, but I'm sorry to ask.
Yeah.
Is there any live sessions for English and stats and this CT and all?
Sorry, what? Your voice is a little bit low. Yeah, just tell me again.
Sorry, wait a minute.
I'm asking that maths notification was there in box over the portal, but link was not there. So these statistics, CT and English, their live session is also there conducting.
Yeah,
you have to put arrow down.
So they conducted it.
They have conducted. I think the stats session is tomorrow. First stats session. I'm not sure about other subject. Anyone can answer her if you guys are familiar with these sessions. Then, have you guys joined any session over these subjects?
Yes,
ma'am. One question.
Yes, ma'am.
What's the question?
There was one session over English on 25th September, right? Is there any other session regarding any other subject?
Today only English and maths.
She was asking before this session, is there any other section? Any other session have happened?
It's almost every day.
I mean, in the calendar, whatever.
Yes, Sridhar, you answer.
Almost every day session.
Yeah. Adya, the thing is like, Vincent, hold on. Sure. Adya, like all the subject that which is there, more or less, they are starting from post 25th, 25th, right? So just put your calendar. As soon as you say that, it will say the calendar already exists. If you see that message, it means your calendar is updated. Based on the calendar only, all the schedule will happen. Unless otherwise
My
there is any
calendar is only showing
changes,
the
then
deadline and this TA session and these live sessions. I'm notified by the inbox over the portal, which shows that these modules, grades, and inbox. There on their inbox, I found these sessions.
No, if you go to Google Calendar, change that into schedule mode. There you can see week, month, and so on. If you change to schedule, then you can see the day by day what is the schedule happening for each subject. Then it will be very elaborate, because when you go with the calendar form, sometimes you won't be able to. It will be kind of superimposed over other. Just go to the schedule method. the format of the Google Calendar, then it lists you each and every event that's happening for every subject.
Okay, so link is also there, na, on over the calendar.
Yeah, all the links will be there. And
oh, okay. Thank you so much. Thank you so much, Shraddha.
Yeah,
Madam, regarding this
below the TA
function,
session, you can see the for the subject this thing. Whatever the recordings will be there below the calendar, it will be in green or blue.
Okay. Thank you, Shraddha.
Madam, regarding this function, how to put it on the graph, that we'll be learning in the course.
How to put it? Yeah, I'll tell some basic rules that how
Tomorrow,
if you
tomorrow itself. Okay.
yeah, if you have some graph, then how you can shift or scale. But the complicated graphing plotting, that won't be here. Although you just need either quadratic, modular, sine, cos, exponential function. That's all.
Okay.
Ma'am, can we leave?
Yeah, Kishore, you have doubt on rational irrational. So what's your doubt?
No, ma'am, I don't have any doubt.
Okay, you don't have, fine. Yeah, you guys can leave now.
Thanks for this wonderful session, ma'am. Good night.
Yeah, good night. Thank you for joining.
Thank you, ma'am. Bye, ma'am.
Good night.
Thank you, madam.
Ma'am.
Good night, ma'am.
Thank you, ma'am. Thank you so much. Have a good night.
Ma'am,
Yes.
actually,
Yes,
that
yes.
I'm asking that in this term I have shared my two notes with my friend, and he is leaving, and he has left this course. I mean that he is not doing this course right now, and he is asking for me all the notes that I am making for week 1, week 2. So should I give or not?
If he is not in this course, then I don't think why he need the notes then.
I don't know. He is asking for me, and I'm.
If possible, try to deny it. Although it's just notes, so I don't think it will harm anything. Notes, it's up to him. Although all the contents are already present over YouTube, so if he want to learn, he can also learn from YouTube also. But if he will force you, you can give the notes.
Okay.
Don't worry. But don't give any personal information, right?
Okay. Yeah, thank you, ma'am. Good night.
Good night.
Ma'am,
Yes.
I'm late for the session. Just joined at the end of the session.
Okay.
Can I know what are the topics will be covered in the session? Someone was speaking about quadratic equation. Is there week 2 content also covered today?
Yeah, actually we cover up to relation and types of relation. You can see this session. I think there's a recording is going on, so you can watch this session over YouTube.
There is no issue, no? I'm just asking for what are the topics of covered in this session?
Yeah, we cover up to types of relation. I mean sets, subsets, union, intersection, Venn diagram, relations, and types of relations.
Thank you.
Number systems, yeah.
Okay, ma'am. Thank you. Bye.
And
Thank you,
Samiksha,
guys.
that from term to term, the term to term, the syllabus changes, is it?
No. It is fixed.
Okay.
So, are you in the previous term? Are you there
As a
in the previous?
qualifier, we have to be there, right? I mean, for all of us who were there in the thing, because I couldn't take math in the final moment, I changed my mind because I had some other schedule coming in, so I couldn't take the exam, so I dropped it. Because all 4 weeks we have to be there, am I right? The first 4 weeks.
Right.
We cannot escape from the part. That is mandatory.
Correct.
One thing I have to tell, there is an issue in the portal. The calculator was not working as fine.
Calendar is not working?
No. Calculator.
Calculator is not working.
Yes, ma'am.
Okay. So
When you try
calculator.
to, if you have access to the dashboard, you can try to enter 100. After any number you put 1, then any number, there is a glitch in that. So you can't do the calculations as well.
Fine, I
If
will
it
tell them
possible,
to.
if possible,
Yeah, I'll
inform.
inform them. Yeah, I have two things.
I already write a mail but they said, I hope the issue will be solved. That's it. There is no helpful.
Yeah,
more.
actually, support team will be bombarded by the questions and queries, so they will miss. So that's why if they, yeah, these are portal related issues. So I'll tell someone else who handle the portal. So I think he can update the link of the book and this calculator thing can fix.
For quick calculation, the calculator is helpful.
Tomorrow,
Yeah,
I
there.
think the
Tomorrow we
calculator
have.
issue is an old issue because on the Discourse I've seen a lot of complaints about calculators.
Oh, okay.
So I think he can use the TCS one, the one that is using the exam.
You're correct, but for the quick calculation, when you see the question and see the calculator, you have to, if you use the TCS calculator, you have to go to another web page.
Yeah.
Although you can download some gate, there's one gate calculator is there. You can download in your smartphone, but again, that's the thing. You have to go to someone else.
Yeah, I'm actually using that in my computer, using the calculation also. But if the calculator also work fine, it will be a plus to us. I mean, that's the issue. When we try learn from it, there is an issue will be like there is a mistake and minus point. I may not feel them.
Okay, yeah, I'll check. I haven't
Try to
used the
take action.
calculator or portal.
The issue is like if you are pressing 1 and by default it is taking decimal. So if I'm pressing 14, it is calculating as 1.4.
0.4.
That's it.
Fine. Yeah, I'll tell them if they can do.
Exam. Sorry, ma'am.
Yeah, Rohit.
Yes, ma'am. For the exam, are we allowed to use calculators?
I think they will provide some calculator over your screen, as they provide over JEE and all exams, na? That calculator.
Scientific calculator was there.
What
Scientific
will it
calculator.
Will that?
Sorry, what?
Just if the calculator is buggy, then
Your voice is breaking.
will it not create a problem, ma'am?
No, it won't create a problem.
Sorry,
They
ma'am. I
will
was
give you a
saying
call.
if the calculator.
If the calculator is there, then
Ma'am, okay, another thing, ma'am, for this full course, do we need to buy a particular type of calculator that will help
you
us?
don't have to buy any calculator. You don't require to buy anything. Yeah, I mean, not calculator.
Rohit, in the exam hall, they don't even allow analog watch. You are only take the, they not even allow the analog watch. You can take your pen or pencil or a transparent water bottle. That's it. They not even.
Right. And right. Because I mean, that's the rule for every competitive exam, whatever competitive GATE, NET, or JEE. There also you are not allowed to carry a watch.
Rohit, and about your calculator doubt, there is a separate calculator. They called TCS calculator was allowed in your screen of exam.
Yeah, there is a calculator over. Yeah, that's why I'm telling. I think there is one calculator over your screen na, that you can access.
They don't provide any physical calculator.
Physical calculator is not right. Only that virtual calculator is there.
They give you a blank sheet. You have to go get with your pen or pencil. You can make do calculation and enter the answer.
Okay, sir. Thank you. Thank you.
Okay, guys, you can leave now. I also leave.
Thank you, ma'am.
Thank you. Good night.
And the next live session will be tomorrow.
Yes, ma'am. It's too late now. It's